Hi friends, this is Pradeep Parikh and I'm again presenting you the solution for 2008. So I hope you are gaining a lot from this video series where I am solving GATE previous year question, of course in a chronological manner from GATE 2003 onwards. So please do let me know, even though I am solving it, but I never claim my omnipotency over it. I just look at the questions, I solve it. If I don't get, I search some solutions, understand it, and then explain to you. Even I am also not sure, means I'm not claim my 100% that whatever I'm concepts or in fact the solutions that I'm giving is 100% correct. So do practice from your end and do let me know if you face any discrepancy in any of the questions that I have provided or any of the solutions that I have provided. I will be happy to resolve all your doubts. So let's start the solution of GATE 2008. So GATE 2008 is a special year for GATE because this question paper was made by Indian Institute of Science, Bangalore, and it is quite more conceptualistic, okay, than any other previous year questions. The toughness level was a bit high this time. And the importance of this paper is generally whenever the questions of ISRO used to come, they used to directly copy few of the questions from GATE question paper. And in I think ISRO 2018, sorry 19, they have copied one question from directly from this question paper. I will solve it later. We will solve it, the entire question paper. But let me tell you that GATE question paper are not only restricted to GATE, because if you are able to solve the GATE question paper, you are getting an entire spectrum of entrance examination which you are able to give. It includes PSUs to some extent because PSU doesn't deal with this numerical shit and all. But questions like ISRO specifically and many other PSUs like ECIL, then previous year FCI, Food Corporation of India, they conducted exam for management trainee. They used to ask questions which were somewhere related to GATE level. Okay, so GATE question is very very important, and for other PSUs which are directly recruiting like Vishaka Steel and all, for that I would recommend you to follow some portals like examveda.com or indiabigs.com. There whatever mechanical stuffs you find, just mug it up. They will ask the questions based on that. Okay, so let's start GATE 2008 questions. So question number 1, in the Taylor series expansion of e to the power x about x is equal to 2, the coefficient of x minus 2 to the power 4 is. Okay, so we have to find the Taylor expansion of e to the power of x, and we have to find the coefficient of x minus 2 to the power 4. You see, Taylor series formula is Taylor series expansion of Taylor series is this one. F of x at x is equal to a is f of x is equal to f of a plus x minus a by 1 factorial f dash a plus x minus a square to 2 factorial f double dash a, and so on. When it comes to e to the power of x, e to the power of 2 plus x minus 2 1 factorial e square plus x minus 2 whole square by 2 factorial e to the power of 2 plus x minus 2 to the power 3 divided by 3 factorial e to the power of 2 plus x minus 2 to the power 4 factorial e to the power of 2. So the coefficient x minus 2 to the power of 4 is coefficient of x minus 2 to the power of 4 is e square by 4 factorial. So e to the power of 2 by 4 factorial, this is the answer. Option C is the answer. Question number 2, given that d square x by dt square plus 3x is equal to 0 at x is equal to 0 is equal to 1 and x dot, that is these two initial conditions have been given. We have to calculate what is the value of x at 1. So let replace x double dot by m square. So let x double dot is equal to m square and x dot is equal to m, and another thing is 1. We will replace this by 1. So it's general characteristic equation that I am saying that in basic differential equation solution, we first convert it into form of characteristic equation, then find the solution of it. So we see here the solution is in terms of imaginary number, that is m is equal to plus minus square root of 3ei. So solution will be x is equal to c1. You just remember this because these are some basic mathematics that we have learned in the first year. X is equal to c1 e to the power of root 3 I t plus c2 e to the power of minus I root 3 minus again repeating, x is equal to c1 e to the power of root 3 it plus c2 e to the power of minus root 3 it. So now you calculate x dot is equal to, just differentiate it with respect to t. Now x of 0 is equal to 1. They have given some initial condition, that is x of 0 is equal to 1 and x dot of 0 is equal to 0. So from there we will calculate the corresponding value of c1 and c2. Okay, now based on that, once we get c1 c2 value, we will put the main equation, I think this one. In the main equation we will put, and we will get the value of x in terms of, means we will get the value of x in terms of t. Okay, now they have asked that what is the value of x of 1, that is what is this, x is equal to 1 by 2 e to the power of square root of 3 ei at t is equal to 1. Yeah, when we put, so you will get something like this. Okay, so if you will observe carefully, now what we will do is we will expand it. Okay, how we can expand it? We can expand, means if you observe, it's Euler theorem, that is e to the power of I theta is equal to cos theta plus I sin theta. If you observe it, it represents the real part of this imaginary number, or Euler theorem. So that is nothing but the cos half into, this is cos root 3 t. So when you put t in the place of t, if you put 1, it is cos of 3. Remember, 3 has to be in radians because root 3 is in radians. So once you put here, you will get the value. When you put 1, you will get is equal to minus 0.16. Okay, so the important point is here you have to put in terms of radians. So whenever you are solving the gate calculator, in the gate calculator, you have to check whenever you are calculating at least degrees. When you are dealing with degrees or the angles, you have to check properly whether you are dealing with degrees or radians. Here we are dealing with radians, so you have to convert that mode from degree mode to radian mode. Now question number 3, limit x tends to limit x tends to 8, x to the power of 1 by 3 minus 2 divided by x minus 8. Now if I pull simply x is equal to 8, I will get in the form of 0 by 0. As I told you previously, in the previous year questions, they have repeatedly asked L'Hospital's rules. So this is not a big deal. We just so this is in the form of 0 by 0. So what I will do, I will differentiate the numerator and differentiate the denominator. So I'm getting something like this. Now whenever if I put x is equal to 8, I will get a perfect solution. That's answer is 1 by 12 is the answer. So it is 1 by 12 is the answer, and the previous one is minus 1.06 minus 0.16. Question number 4, a coin is tossed 4 times. What is the probability of getting head exactly 3 times? Okay, so here you see this is a discrete type of random probability variable. Okay, this is discrete type of variable. So if we are dealing with a discrete random variable, we use either Poisson's ratio or Poisson's distribution or binomial distribution. Okay, so even though they have not mentioned anything, but still I will try to solve in both the methods. First binomial distribution and second Poisson's distribution. So let n, number of trials is 4. What is probability of getting h? It is half. Now what is x? That is number of, what is expectation? It is 3 times head we need to get. So for binomial distribution, p and x belong, we use binomial distribution when p and x belongs to the same result, that is getting heads. Okay, so what is the probability of getting heads exactly 3 times, that is x is equal to 3 times, is ncx p to the power of x q to the power of n minus x, where q is equal to getting tails. Okay, not x, q is not getting heads. So 4c3 half to the power 3 into half to the power 1. This half represents the number of arrivals of not getting head, rather tails. This is the probability of getting heads. So if I solve it, I will get 1 by 4 is the answer. So here answer is 1 by 4, but still I will solve it in a Poisson's distribution also. So for this using binomial distribution, I get probability of getting heads thrice out of 4 tosses using binomial distribution, I am getting 0.25 as my answer. Now, as I told you that discrete random variables, we can solve either Poisson's ratio or Poisson's distribution or binomial distribution. Now, I will show you how Poisson's distribution, through Poisson's distribution, we will solve this. You see, using Poisson's distribution, the probability of any event, happening of event is e to the power of minus lambda into lambda to the power of x divided by x factorial. Now where mean or expectation, that is what we expect, is n into p. N is the number of times we are number of times we have done the trial. P is the expectation. Okay, so lambda is equal to 4 into this is lambda p, sorry, lambda p is equal to lambda, correct, lambda is equal to n into p. 4 times we are tossing it, and what is the probability getting heads? Half. So lambda is equal to, that is mean or expectation, is equal to 2. Now p getting 3 heads. So what is the probability getting 3 heads? As I told you, this is the formula, probability function, e to the power of minus 2 to the power 3, because x is equal to 3. So here I have not mentioned, but here x is equal to 3. So x to the e to the power of minus 2 to the power 3 divided by x factorial, that is 3 factorial. I will be getting 8 divided by 6 e square, that is equal to 0.1804. Since it's not in the option, but binomial distribution is the option, so answer is 0.25. So basically the reason behind I solving it, I want to show you how the binomial distribution and Poisson's distribution work in a probability system. The common thing between those two is these both are actually used for solving discrete random variables. Okay. Now, question number 5. A matrix 1, 2, 4, 3, 0, 6, 1, 1, p has one of the eigenvalue 3. The sum of the other two eigenvalue is. It's very simple. We know that the sum of all the eigenvalue are the sum of the sum of the main diagonal. So 1 plus 0 plus p is equal to 1 plus is the sum of the eigenvalue. One of the eigenvalue is 3. So p plus 1 is equal to 3. Then the other one is p minus 2. Okay. So lambda 1 plus the sum of the other two is p minus 2. So it will be option C. Question number 6. Divergence of a vector field x minus y I cap plus y minus x j cap plus x plus y plus z k cap is. Divergence, we can say this generally represented by del. Okay. Divergence is an operator. Del is an operator. Divergence can be written as with the dot product of the del operator. So this dot product with my vector. This is dot product with my vector. So if I make the dot product, I will be getting 1, that is del x I cap into x minus y I cap. So del by del x x minus y cap, del by del y j cap into the dot product of y minus x j cap. Then del by del x k cap, dot product of x plus y plus z k cap. From here I get 1 plus 1 plus 1, that is equal to 3 is the answer. Question number 7. The divergence of a vector field x plus, question number 7, yes. The transverse shear stress acting in a beam in a rectangular cross section subjected to the transverse shear load is. So I think if you have observed the GATE syllabus properly for GATE 2021, you will find that shear center, the concept of the topic of shear center has been added. So this is this particular thing, that is shear stress, belongs to that particular topic only, where we are calculating shear stress varying across the transverse direction. So I'm not giving much detail because in the coming sessions I will be explaining you the entire distribution, what is the formula, how we derive these things. But for the time being, just remember the shear stress in a rectangular cross section. Most of the cases, most of the standard cross sections, the shear stress vary in this way, in a parabolic way. In rectangular specifically, the shear stress at the ends will be 0 and it will be maximum at the center. Okay, so it is parabolic in nature. So if you look at the question, variable with maximum at the bottom of beam, no. Variable at maximum at top of the beam, no. Uniform. Variable with maximum at the neutral axis. So option D is the correct answer. So variable with maximum at the neutral axis. Now question number 8. The rod of length L and diameter D is subjected to load P. Which of the following is sufficient to calculating resulting change in diameter? Rod of length L and diameter D. Okay, okay. So we need to calculate the resultant change in diameter. First, we know that mu is equal to, that is Poisson's ratio is equal to lateral change change in the dimension by longitudinal change in dimension. Okay. Now this delta L by L can be, they have given the value of L. Delta L can be found using E. Okay, that means they have not mentioned anything regarding E. So if I get the value of E and I have the value of mu, then I can find the value of corresponding value of resultant change in diameter. Yes, but if you find E and mu is not there, they have only option 1, Young's modulus, shear modulus, Poisson's ratio, both Young's modulus and shear modulus. See, individually, if you have only either one of these, we cannot find that delta D. But if you know both Young's modulus and shear modulus, then we can find the value of mu, because shear modulus itself doesn't have any use here. Using the shear modulus, we can find correlating shear modulus with Young's modulus, we can find the corresponding mu with this formula. E is equal to 2G1 plus mu. From here, you will find the value of mu. From here, once you get the family of mu, that is Poisson's ratio, just put it here and you will get the value of delta D. Question number 9. A straight rod of length L of T hinged at one end. Okay, the length is varying with respect to time, we can say. Hinged at one end and freely and extensible to the other end, rotates through an angle theta D. At a time L of T is equal to 1 meter. L dot of T, if you observe, it is L dot of T, there is a dot here. L dot of T is equal to 1 meter per second. Then theta of T, that means angle at any time T, is pi by 4, and theta dot of T, that is angular velocity, is 1 radians per second. So we have to calculate the magnitude of the velocity. The magnitude of the velocity at other end of the rod is. So we have to calculate the magnitude of the velocity at other end of the rod. So you will find there are two things mentioned, L and theta. That means we are dealing with two things, the translatory motion as well as rotational motion. That is we have to find magnitude of the velocity at the other end, right? So in terms of velocity, we can say we are dealing with linear velocity and angular velocity. Now, if you observe angular velocity, you see they have given, that means if I show you the diagram, in this direction it is the linear velocity, and since angular velocity in this direction, omega into r, you will give the angular velocity in this particular direction. In terms of, if you want to convert the angular velocity into omega, rather linear, in linear terms, it will be in this form. Okay, so linear velocity is 1 meter per second, they have already mentioned. Angular velocity is 1 meter per second. How you calculated it? This is theta dot, and if you multiply with respect to 1, because we know that v is equal to omega into r. Omega they have given 1 radians per second. Just multiply with the corresponding radius. If you multiply with the corresponding radius, that is 1 meter, at that instant you will get 1 meter per second. So let me clearly mention it. Linear velocity is equal to this. Angular velocity is 1 radian into 1 meter, that is 1 meter per second. Okay, so I don't need to mention here. So 1 meter per second. So these two are in perpendicular direction, so resultant velocity will be square root of 1 square plus 1 square, that is equal to square root of 2 meter per second. Answer will be square root of 2 meter per second. Now question number 10. A cantilever type gate hinged at Q is shown in the figure. P and R are the centers of gravity. Centers of gravity of cantilever part and counterweight respectively. Okay. The mass of the cantilever part is 75. The mass of counterweight for a static balance is. Okay. You see here the cantilever type gate hinged at Q. So cantilever type gate hinged at Q. The figure P and figure R are center of gravity of cantilever part and counterweight respectively. P is the cantilever part. Cantilever part, this is counterweight part. The mass of the cantilever part, this P is 75 kg. The mass of the counterweight we need to calculate. It is hinged at this. So what we can do, we can simply take summation at Q is equal to 0. Once you take, you can easily find the weight of the counterweight. Weight of the counterweight. That is, I solved it, I got 300 Newton. So answer is not 300 Newton, rather it's 75 kg I took. Actually, I have not taken the value of G. That is a, if I multiply it 10, I will be getting somewhere like 300 Newton. And if you convert it in roughly, you will get Fr is equal to 300 kg. So answer will be 300 kg is my answer. Okay. Now question 11. A planar mechanism of 8 links, 10 rotary, the number of degrees of freedom of a mechanism using Grubler's criteria is. So we know that Grubler criteria for planar mechanism, the formula is 3 into n minus 1 minus 2j minus the higher pairs, but higher pairs are not there, so we won't consider it. Only the lower pairs we will consider. This is 3 into n minus 1 minus 2j. So 3 into 8 minus 1 minus 2 into 10, that is equal to 1. So answer is 1. Question number 12. An axial compressive stress due to manufacturing process is present on the outer surface of rotating shaft subjected to bending. Under the given bending load, the fatigue life of the shaft in the presence of residual compressive stress is. Okay. So what they have asked is the axial residual compressive stress due to manufacturing is present on the outer. So basically, after the manufacturing of the component, initially what is there? Here there is some residual compressive stress is acting. Okay. Here some residual compressive stress is acting. Okay. Now residual compressive stress due to manufacture is present on the outer surface shaft subjected to bending. Now it is subjected to bending. Under the given bending load, the fatigue life of the shaft in the presence of residual compressive stress is. So once it is given bending, so these it will succumb what? It will succumb tensile. Okay, that means what will happen is it will not bend further. Rather, there. So at the top surface, what you will find? At the top surface, what you will find? You will find tensile because of bending and residual compressive stress at the surface. So what will happen is it will try to repeal the compressive effects or neutralize the compressive effect, due to which what will happen, you will increase the fatigue life. It's a very conceptualistic question. If you read it properly, you will get it. So again repeating, the axial residual compressive stress due to manufacturing process is present on the outer surface of rotating shaft subjected to bending. Under a given bending load, the fatigue life of a shaft in the presence of residual compressive stress, it is increased. Why? Because at the surface, let's say this surface, due to the bending, it will succumb tensile force, and it has already some residual compressive stress, due to which it may its life by default get decreased because of the residual compressive force. But due to the bending, it is try to elongate those compressive stress, due to which what will happen, it increases the life of the component. Very interesting question. Now question 13. 2 moles of oxygen are mixed adiabatically with 2 moles of oxygen in the mixing chamber, so that the final pressure and temperature of the mixture become same as those of individual constituent of the initial states. The universal gas constant is R. The change in entropy due to the mixing per mole of oxygen is. So whenever the fluid is mixed, it undergoes whenever two fluids are mixed, you have to remember, means such that initially the fluid temperature is T1 and final temperature is T2, and they are mixed. Suppose there are two fluids initially having T1 temperature and the second fluid having T2 temperature, and they are mixed so that final temperature become TFs. At that case, the entropy is given by this formula. Okay. Now it has been told that the final total pressure and the temperature of the mixture become same as those of individual constituent. That means the temperature is also same. That means 2 moles of oxygen mix adiabatically itna, so that final temperature. Okay. So if it is saying that final temperature is becoming same as that of their initial temperature, that actually mean that all three are in thermal equilibrium right now. Means whatever temperature was 1 is equal to the temperature of the second mole of oxygen, means the first container temperature is equal to second container temperature is equal to final temperature. That is given by Tf square divided by T1 into T2, or we can say Tf square by T initial square, that we can say Tf, it is Tf is equal to T initial. That means this part will become 1 and this entire thing, this change in entropy will become 0. Now the most important thing is, here you need to remember this formula. Suppose the two fluids are mixed with a different temperature. Initially say T1 T2 are the temperature of individual fluid, finally they mix to become Tf square. Then what will be the corresponding change in entropy? Just remember this formula, because this is a standard formula that you come across, and putting the value here, you will get the value as 0. Answer will be 0. Question number 14. If a fluid flows over a heated plate, the following fluid property are known: viscosity, specific heat at constant pressure, thermal conductivity. Hydrodynamic boundary layer thickness is specified, the location is 1 mm. The thermal boundary layer for the same location is. So we know that if I want to correlate fluid mechanics with heat transfer, then there is then we can do it using the thermal boundary layer and the hydrodynamic boundary layer. So the formula which correlates the fluid mechanics with thermodynamics is delta V by delta T is equal to Prandtl to the power 1 by 3. Okay, and what is Prandtl number? Prandtl number is given by mu Cp by K. Mu is the dynamic viscosity, Cp is the specific heat at constant pressure, K is the thermal conductivity. So Prandtl number is equal to mu Cp by K. If I found it is 1, and Prandtl to the power 1 by 3 is nothing but 1 only. That means my hydrodynamic, let me write that formula also. Prandtl to the power 1 by 3 is equal to delta H by delta T. Okay, so if Prandtl number is coming 1, that means my hydrodynamic boundary layer thickness is equal to thermal boundary layer thickness. So they have mentioned thermal boundary layer thickness at the point. We have asked thermal boundary, and they have given hydrodynamic boundary layer thickness at a specified location 1 mm. So here thermal boundary will be same as 1 mm. So question number 15 is, for the continuity equation del vector dot v vector is equal to 0 to be valid, where v is the velocity vector, which one of the following necessary condition? Which is the necessary condition? Now when we say continuity equation, we need to say that change in volume, rather volume is almost constant throughout the, that means del of del x with respect to this volume means rho into a into e u with respect to x is almost 0. Okay, there is no such change in volume. Now for any particle, now what is mass flux rate of this? We can say mass flux rate means mass per unit area, that we can say it is rho u. Okay, remember this whenever we calculate these type of things like del vector dot v vector, we generally take rho into u, because we consider mass flux rate at any cross section. So that is equal to del by del x I cap plus del by del y j cap plus del by del z u cap k cap is equal whole dot product into rho u I cap plus rho v j cap plus rho w k cap is equal to 0. Okay, now if you will differentiate it, we will find something like this. Okay, you will get something like this. Now this equation is only valid when it is incompressible. That means rho is constant. Okay, when it is constant, it is, so this equation is only valid. That means our continuity equation, this particular thing is only valid when our delta is constant. That means delta is not changing with respect to the direction or any other parameters. So when I'm sorry, not delta, it is rho. Density is not changing with respect to any other parameters. So when our density is not changing, it is called incompressible fluid. So therefore, this particular equation del dot v vector is equal to 0 is only valid for when our rho, that is density, is not changing, that is called incompressible flow. And this equation is valid for steady as well as for unsteady flow also. That means if the velocity is changing with respect to time, then also it is valid. Okay, so this equation is valid for steady and unsteady flow. Only condition is the fluid should be incompressible flow. Okay. Now question number 16. Which one of the following is not a necessary assumption of air standard Otto cycle? Okay, if you observe it, the intake and exhaust process are constant volume heat rejection. No, intake and exhaust process are constant volume heat rejection, because in intake we generally, if I make the Otto cycle first, you will find in intake 1 to 2, or rather constant volume heat addition, this is Q in and this is Q out. Okay, 1 2 3 4. So this is also V is equal to constant, this is also V is equal to constant. These two graphs represent constant volume curve. They are parallel, or not parallel but symmetrical graphs, symmetrical slopes. So in 1 2 to 3 it's constant volume heat addition, in 1 to 4 it is constant volume heat rejection. So intake has to be the constant value heat addition and exhaust has to be constant volume heat rejection. Rest all other assumptions are correct. That is, all the process are both internally as well as externally reversible. It is correct. Then the combustion process is at constant volume heat addition, correct. Then the working fluid is an ideal gas with constant specific heat. That means specific heat is not changing with respect to the temperature. Now question number 17. In MM1 queuing system, the number of arrivals in a interval of length t is a Poisson's random variable. The probability of there being arrival in the interval of a length t is given by e to the power of minus lambda t to the power of n divided by n factorial. Okay, when you say lambda t, I think if you correlate with, I think 10 questions before, when I solved one questions in Poisson's distribution, in terms of Poisson's distribution, you will try to know, or you will try to get that this n is the probability there being n arrival. What is this n? N is the number of, is the expectations. N is the expectation. Now what is lambda t? Lambda t is mu. Okay, and n is again the number of favorable outcomes, we can say. Okay, so here n is the expectation, lambda t is the mean. So what is the probability distribution function for this? Probability distribution function will be this one, lambda into e to the power of minus lambda t. This is the probability distribution function for this. Okay, now question number 18. For this is the answer. Now the set of 5 jobs is to be processed in a single machine. The processing time in days is given for a table below. The holding cost of each job is k per day. The schedule minimizes the total inventory cost. Okay, so based on, I think, shortest processing time, right? Schedule the minimize the total processing. So they have given the processing time. Now in order to minimize the total inventory cost, they have not mentioned anything. So we will arrange in terms of their shortest processing time, SPT. That means the processing time which is lowest, it will be coming first. So T has a processing time of 1. So T, then come S, which is 2, 3, I think S or Q. We can write either way, that it doesn't bother. Either T, Q, S, R, P or T, S, Q, R, P. If you observe T, Q, S, they have not mentioned anything. Therefore, these are the two possible ways. They have not mentioned this in the option. So this is the answer, TSQRP. TSQRP. So option A is the answer. Okay, this is based on the shortest processing time, SPT. Question number 19. For generating Coon surface you require, actually this is a theoretical question. If you don't know, then you cannot guess also. So for generating Coon surface we require, so what is Coon surface? Coon surface is obtained by blending four boundary curves. It has the ability to fit a smooth surface through a digitized point in a space such as those in the reverse engineering. So It is basically, answer is we require 4 boundary curve defining the surface. Okay, I'm sorry, I cannot explain because this is directly coming from a definition, so we cannot help. So it's best way to this is just remember this. I again say this is 2008 question paper. This has been said by Indian Institute of Science, Bangalore. So you will find some sort of in-depth concept. Okay. Question number 20. Internal gear cutting operations can be performed by. Internal gear cutting is shaping with pinion cutter. Answer is shaping with pinion cutter. Question number 21. Now question number 21 to 75 is a 2-mark question. As I was telling that the GATE question paper is not act as a benchmark for GATE aspirants, but also for the aspirants who are also preparing for exams like ISRO examination or any other examination which sets the question on numerical type. So this question 21 was asked in ISRO examination 2019. Yes, 2019 ISRO examination. They have directly given this. So if a person who don't know, he may guess that the shaded triangular region PQ shown in the figure, what is integration of x, y, dx, dy? He may think that this represents area and simply half base into height, I will be getting answer 1. No, x, y, dx, dy doesn't represent the area. Okay, it's dx, dy represents the area. Now now how we'll solve it? The first what we'll do, we will find the corresponding equation of this particular line. Okay, if you get it, you will get y by 1 plus x by 2 is equal to 1. Now what we will do, we will take a small area, this one, if you see in the red. So here the y is varying. How the y is varying, we will first write in terms of y, how things are varying. Okay, so this is xy dx dy, so we will convert in one variable form. So y I can convert in terms of 2 minus x by 2. Okay, now x into 2 minus x by 2, and then I will process. So I will put it here, y is equal to this much. Okay, so integrating 0 to 2 and again integrating 0 to 2. So here how the y is varying from 0. Here y is 0 and here y value is 2 minus x by 2. Okay, here the value of y is 2 minus x by 2. And how the x is varying from 0 to 2. Okay, now if you see here, if you see if you just integrate with respect to y, say I will get y square by 2. Now how y square by 2, I will the limits is 0 to 2 minus x by 2. So 0 to 2 minus x by 2, and then again I will, so again whatever I will get a complete equation in terms of x. I will expand it, and again I will integrate with respect to 0 to 2 because x is varying from 0 to 2, and when I will solve it and finally get an answer as 1 by 6. So the correct answer for this is 1 by 6. It may look very simple, but actually it is quite tricky, because here we will put the value of y in terms of limit. We will first integrate the y and then put the value of y in terms of limit in order to get a uniform variable here, and then after that it's a plain integral. So the concept lies till this point. Once you got this, everything is simple. Now question number 22. The directional derivative of a scalar function f of x, y, z, that is x square plus 2y plus z at a point 1, 1, 2 in the direction of a vector. That means we have to find the directional derivative of the scalar function in this vector direction. Okay, how to find this vector direction? We know that in order to find the vector direction of this vector, a vector is equal to a vector divided by the magnitude of a. And what is the directional derivative of this? It is del by del x I cap of this particular vector. So if you find the directional derivative, you will get a vector form. Okay, now once you get the vector form, you just take a dot product in the directional derivative of means in the direction of a vector. So simply take a dot product of this del vector dot this, and you will get the corresponding value as -2 is answer. Okay, so I hope you understand. If you don't understand, do let me know in the comment section. Everything has been done from my end. First we find the directional derivative, and then we will find the angle, that is with respect to this vector. A vector divided by a vector magnitude represents the direction of this vector, and this when you take the dot product of this representing aligning the directional derivative of this f vector, f function, with respect to this direction, a direction, a vector direction. This answer is -2 is the answer. Now question number 23, for what value of a, if any, for what value of a, if any, will the following system of xyz will have solution? I have discussed in the past, in order to get a unique solution, what we have to do, we have to check the rank of the matrix. Okay, first this matrix, and then the augmented matrix. Okay, that is a slash b. So the rank of A matrix should be equal to the rank of B matrix. Now if I solve here, I found that rank of A matrix is equal to 0. That means now the determinant of this particular matrix has to be 0 in order to get some correct solution. That means so 2 3, yeah, 2 3 0. Okay, so now this vector has, so in order to get a solution, that means unique solution, or rather solution, rank of a matrix should be equal to the rank of a augmented b. So a matrix is equal to 0. That means the rank of this matrix has to be 0. Okay, so if I take the determinant of it, and I will get the value of a. So here I am getting the value of a as 0. So answer is 0. Now question number 24. Which of the following integral is unbounded? You just take the integration of it. Integration tan x dx. Tan x dx is equal to sin x by cos x dx. That is ln cos x 0 to pi by 4. It is bounded. Okay. Now unbounded means I am not getting a perfect solution of it. Now integration 0 to infinity 1 by x square plus 1. If you get tan inverse x 0 to infinity. Now tan inverse x means tan inverse infinity means pi by 2. Tan inverse 0 is 0. So answer is pi by 2. It is bounded. Now integration 0 to infinity x e to the power of minus x dx. It is x integration e to the power of minus. This is actually the integration by parts, where this is the first function, this is the first function, and this is the second function, based on Ellet principle. X integration e to the power of minus x dx minus integration double integration of e to the power of minus, because we have taken derivative of the first function as 1. So here derivative of function is first function would be 1 into e to the power of minus x dx. If you solve it, you will get something like minus e to the power of minus infinity minus x limits 0 to infinity. So from here you will get answer is 2, because e to the power of minus infinity is 0. So you will get 2, which is bounded. Now the fourth option, integration 0 to 1 by 1 minus x dx. So here you will get minus ln 1 minus x limits 0 to 1. If you solve it, minus ln 0 plus ln 1. ln 1 is 0, we know. ln 0 is unbounded. So the correct option for this is option D. Now question 25, the integral, cyclic integral f of z evaluated around a unit circle of a complex plane cos z by z is. Okay, so if f of z is an analytical function within and on the closed surface curve C, they have mentioned the curve C, they will be giving in the question. So if A is any point inside the curve or inside the curve C, then f of A will be 1 by 2 pi I cyclic integral of f of z divided by z minus a dz. Therefore, cyclic integral of f of z, what they have asked, I think, cyclic integral of f of z by z minus a dz. Here they have given a value as 0, okay, is equal to 2 pi I into f of a. At z is equal to 0, because they have mentioned cos z, f of z is equal to cos z by f of z is equal to cos z by z. Only z is there, that means z minus 0. So z is so the point where we need to find is at the center. So at z is equal to 0, lie inside. Okay, so z lies inside, therefore 2 pi I cos 0, that is equal to 2 pi I is the answer. So I'm again repeating this. This is actually the way to find the integration of a complex integration. So if f of z is an analytical function within and on the closed surface C, and A is any point inside C, then f of A, what is f of A actually? See, they have integration of, that is integral, cyclic integral of f of z dz evaluate around the unit circle on a complex plane for f of z is equal to cos z divided by z. Okay, so for A is the point that is lying inside the circle, so f of A is equal to 1 by 2 pi I cyclic integral of f of z divided by z minus a dz. So cyclic integral of f of z, z minus a, cyclic integral of f of z, z minus a dz is equal to 2 pi I f of a. Okay, so what is this f of z here? This f of z is cos z by z. Okay, here cyclic integral of cos z by z minus 0 dz they are asking. Okay, they are asking. Now the point 0, if you look at, it's actually a unit circle in the complex plane. In unit circle, if it is unit circle, it means the radius is unity. It means that radius is unity, and this point 0 is actually a real number, real 0 lying at the center, which is like well within the curve. Okay, within the curve. So this a value is 0 at z is equal to 0, lie inside. Then the answer will be 2 pi I f of a. So 2 pi I f of a means 2 pi I f of a means 2 pi cos of 0, that is equal to 2 pi I is the answer. Okay, now question number 26. The length of the curve y is equal to 2 by 3 x to the power 3 by 2 between x is equal to 0 to x is equal to 1 is. So just remember this formula. Length of the curve is given by square root of 1 plus dy by dx whole square. Now what is dy by dx whole square? So we will find first dy by dx and then square it off. Okay, so dy by dx is equal to 2 by 3 into 3 by 2 raised to the power of x to the power of half. And what is its square? Its square is this, that is equal to x. Okay, so it is integration 0 to 1. What is so it is integration from x is equal to 0 to x is equal to 1. 0 to 1 here, x is equal to 0 to x is equal to 1, square root of 1 plus x, that is x to 1 plus x to power of 1 by 2 dx. So if I solve it, I will be getting it's 1 plus x to the power 3 by 2 divided by 3 by 2, or we can say 2 by 3, 1 plus x to the power 3 by 2. Okay, now x will take the limits from 0 to 1, and once we take the limit, I am getting an answer 1.21 as my answer. So 1.22 is the answer, nearest. Question number 27. Eigenvalues or rather eigenvectors of a matrix 1 2 0 2 are written in the form of 1a 1b. What is a plus b? So before finding the eigenvectors, we need to calculate the eigenvector values. So we know that eigenvalues, we can rather find the eigenvalues through simple calculation also, or we can use a simple trick. That is, we know that the eigenvalues, the sum of eigenvalues are sum of the eigenvalues are sum of the diagonal matrix 1 2 3. That is, sum of eigenvalues 1 plus 2, that is 3, and product of the eigenvalues is the product of determinant. That is, the product of the eigenvalues is 2. The determinant is also 2. So product of eigenvalue lambda 1 plus lambda 2 is equal to, and lambda 1 plus lambda 2 is equal to the sum. Okay. So yeah, the product you see here, therefore I found that eigenvalue is 1 and 2 because their product is 2 and their sum is 3. Now we have to find that eigenvector. Let's say so basic concept of eigenvector is ax minus lambda x, that is a minus a minus lambda I a minus lambda of x, rather ax minus lambda x. You just remember this, ax minus lambda x is equal to 0. Now I will put the value of lambda is equal to 1. For lambda is equal to, for first eigenvalue, I will get something like this, that is 2x2 is equal to 0, that is x2 is equal to 0. That means no matter what is the solution for x1, x2 will be 0. Okay, now for lambda is equal to 2, I will be getting minus x1 plus 2x2 is equal to 0, that is 1 and 1 by 2. If I observe it, I will get 2 by 1. Okay, if I solve, I will get something like 1 by, in normalized form if I write it, I am getting 1 and 1 by 2, because in the eigenvector they have mentioned something like this, 1 by a and 1 by b. So first, I in a normalized form I write 1 and my a value, suppose a is 0. Let me take the first is a. The second, if I write in a normalized form, I am getting 1 and half. Okay, in a not normalized form I can write 2 1, but in a normalized form I will write 1, because the first term I will write in the column matrix as 1, and the below one becomes half, so this b will become half. Okay, and this one, what is a plus b, it is 0 plus half, that is equal to half. 0 plus half is equal to half. The answer is half. Question number 28. If f of x is equal to y to the power of x, what is del square f by del x del y at x is equal to 2, y is equal to 1? Now what we will do is, f is equal to y to the power of x, ln f is equal to x ln y, that is 1 by f, del f by del y is equal to x by y. So what is, from here what we get, del f by del y is equal to x by y to the power x, that is del f by del y is equal to x to the x into y to the power of x minus 1. Now what is del square f by del x del y? That is, it's a simple, because when we are differentiating, partial differentiating with respect to x or y, say in this case I am differentiating with respect to y, I will keep y as my variable, but in terms of x, x is remain constant. Okay, so here so del y by del x, del f by del y comes as x y to the power of x minus 1. Now we will differentiate with respect to x. Now x becomes variable, so it's a product rule of differentiation, that is rather chain rule. Y to the power of x minus 1 plus x into y to the power of x minus 1 ln x minus 1. Okay, now I will put the corresponding value of x is equal to 2 and y is equal to 1. I will get solution as 1. So here answer is 1 for me. I hope you understand the partial. This is the simple application of partial derivative, nothing else. Now question number 29. Question number 29. It is given that y double dash plus 2y dash plus y is equal to 0. Y of 0 is equal to 0 and y of 1 is equal to 1. What is y of 0? So basically we need to solve this differential equation and put find the value at x is equal to 0.5. So we know that it can be written in characteristic equation is m square plus 2m plus 1. So m plus 1 square is equal to 0. That is m is equal to minus 1 and minus 1. So the general equation will be y is equal to, so in this case where we get a common root, where the general equation is y is equal to c1 plus c2x e to the power of minus mx, or rather mx. So c1 plus c2x whole into e to the power of minus x. So y of 0 is equal to 0, I think y of 0 is equal to 0. When I put y is equal to 0, I get c1 value is equal to 0. Then y of 1 is equal to 0. When I put y of 1 is equal to 0, I get again c2 is equal to 0. Therefore both c1 and c2 is equal to 0. That means y is equal to 0. No matter whatever value you put, no matter whatever value of x you put, the y will always be 0. Now question number 30. The strain energy stored in a beam having flexural rigidity, it's EI. It's not FL, it is EI. It is flexural rigidity EI and loaded as shown in the figure. Okay, we have to find the flexural rigid. We have to find the strain energy stored. Okay, so as I told you, I think in the previous question paper 2007, the same concept was asked with respect to torsion. So with respect to torsion they have asked. So the same thing we will do here, but we will do it in some different fashion. You see, there are 2 points where the load P has been is being acting. Okay, so there are 3 sections now: section 1, section 1, section 2, and section 3. So what we will do, we will first calculate the normal reactions. Since P and P are acting at a symmetrical in a symmetrical fashion, so the reaction will be same, P and P only. Okay, now what we will do, we will first calculate the moment across this bar 1, section 2 and section 3, not bar 1 bar 2, it's section 1 and section 2 section 3. Okay, we will calculate first. So I calculated taking the shagging, taking it from the left hand side, that is from say point A, and this is point B. This is point D, I think I have taken. Yeah, I took point this as D, this point I have taken as B, and this point I taken as C. So so moment about the moment equation about the AB will be Px, and x lies between 0 to L. Okay, now I will take moment from this point. I will take the equation from this point, that is my x will be varying from 0 to 2L. Okay, because if you observe the question, you will find this is L, 2L and L. So I will take the equation such that this is from 0, x is varying from 0 to 2L. So moment at BC, I will be getting a constant moment that is equal to PL from x is equal to 0 to 2L. Okay, now again if I take the moment from from here, I will find my moment equation is PL minus PX, where x is varying from 0 to L, because this is the length of L. So these are the 3 moments at the 3 sections I found. Now what I will do, strain energy in the AB, in the section AB, since the length of the AB is varying from 0 to L. So the strain energy is very simple, m square dx divided by 2EI. This is the formula for the strain energy. That is m square dx by 2EI integration from 0 to L. So just put the equation of the equation of mx, that is p square x square dx by 2EI integration from 0 to L. Again strain energy in the BC will be this BC, the net moment that is acting is PL, that is constant. So it will be PL whole square dx EI from 0 to 2L, because the length is varying from 0 to 2L. Now strain energy in CD, will be, this length is varying from 0 to L. So just put the formula of the moment, that is PL minus PX whole square dx by 2EI, and integrating from 0 to L. So just put it and you will get the answer. So whatever strain energy, whatever we have got, this one and this one, the strain energy of the entire beam will be, just add it, simply add it, and you will get total strain energy of the beam, where when this type of loads are acting, is 4 by 3 p square L cube by 3 EI. So answer will be 4 by 3 p square L cube by 3 EI. Now coming to the question number 31, it's a very beautiful question. Now you see here, they have given a point P. I think I have marked here with a black dot, point P. So they have asked the axial stress acting at a corner of point P. So if you observe it carefully, what type of forces that are acting? As I told you, that the forces that will be acting, so in order to find it, you will just shift this force to this axis and the corresponding moment. So this force is acting, this force is actually taking this as a centroidal axis or neutral axis. The moment that is acting is F into L minus B. Okay, this is the moment that is acting. I have mistakenly taken L, but actually it is L by L minus B. F into L minus B. Okay, this is L minus B. F into L minus B is the moment. So if I consider only this particular portion, I can say in this way. This is the P, that is force that is acting. Okay, downward. It is rather F. We can say it F. This is also F. This is the point P. Okay, F into L minus B. This is the moment that is acting, because it is tending to move this bar in a clockwise direction. But because since there is a support, there is a opposite couple, that is a moment that is acting in anti-clockwise direction. Okay. Now, therefore, P is experiencing 2 type of forces. What? First, the direct force, and second, the tensile force because of this moment. Okay, if you see, this is the upper layer, and this upper layer is executing a tensile force. So there are 2 forces. First, the direct stress, and second the bending stress. Okay, so what is direct stress? Direct stress formula is F divided by area, 2b into 2b. Now bending stress is M by I into Y. F into L minus B, this is the moment, into B. Because this is 2b, they have mentioned that this is 2b. So since it is acting at, suppose, at this point, okay, so from the neutral axis this is B. M into Y divided by I. So F into L minus B into B divided by 2B to the power 4 by 12. So from here you get the bending stress is this much. Now the total stress acting will be just summation of this. FB by 4B cube plus 3 into F into L minus B by 4B cube. Just solve it and you will get the answer as F by 4B cube into 3L minus 2B. It is 3L minus 2B. Is there anything wrong that I did it? No, this is the answer. So this is the answer. F by 4b cube divided by 3l plus 2b is the answer. Let me confirm. Yes. Sigma is equal to F by 4b cube divided whole into 3l minus 2b is the correct answer. Okay, it is not plus, it is rather minus. F into 3l minus 2b divided by 4b cube. Okay, do check from reevaluate from yourself and do let me know if I am giving the correct answer or not. I think this is the correct solution. Anyways, the concept is the P will suffer from direct stress as well as bending stress. Now suppose just change the location of P from this point to say this point. If you shift the location from this point to this point, you will find that this point is executing a compressive bending stress, not a tensile bending stress. So this will be in minus form. This will be in minus form. Okay, but as per the question they have given, it is both in tensile. So let us see question number 32. A solid circular shaft of diameter 100 mm is subjected to an axial stress of 50 megapascal. It is further subjected to a torque. It is further subjected to a torque of 10 kilonewton meter. The maximum principal stress experienced by the shaft is. So this particular shaft is experiencing axial stress as well as a torque. So due to the torque, it will experience a shear stress. Okay. So due to the torque, first we calculate what is the shear stress, the maximum shear stress that is executing it. If you will just use the torsion equation, T by J is equal to tau by R. So from here you get the shear stress. The shear stress is 50.92 megapascal. Okay, in order to remember the formula, you can remember the formula, that is 16 T by pi d cube. Okay, so from there you can find the shear stress that is experienced by the top surface of the body due to this torsion. Now what about the sigma, that is the direct stress? It is 50 megapascal. Okay, now since this body is executing two things, that is first axial stress, and which is tensile in nature, and shear stress. What is the maximum principal stress experienced on the shaft is closest to? So maximum principal stress is sigma by 2 plus minus square root of sigma by 2 whole square plus tau xy square. Okay, since it is only experiencing sigma in one direction, so we won't take the the stress at the other direction. The other direction stress will be 0. So just put it and you will get the answer as 81.76. So answer here is 81.76, nearly equal to 82 megapascal. Question number 33. You see, this is a beautiful question. A circular disc of radius r rolls without slipping at a velocity v. Okay, this entire remember, this is pure rolling condition and it is rotating at a velocity, that means a linear velocity with respect to the center is v. They have shown the magnitude of the velocity at a point p. So what is the, so first of all we find the instantaneous center. We know that instantaneous center for a pure rolling body will be lie at the point of contact with respect to ground. Okay, now so if I make the diagram, the corresponding diagram will look something like this. This is I, instantaneous center of it, and p, the rotation of p will be somewhere like this, perpendicular to its ip. And what about o? O is moving in this direction, and since this is a single body, single unit, so the angular velocity will be same for both. That means v by ip, that means velocity with respect, this means omega of center is equal to omega at p, that is vp, velocity at point p, divided by ip, that is distance from the eye center, is equal to vo divided by io, that is oi. So vp is equal to vo into ip by io. Now what is ip and what is io? Io, we all know that it is radius. This also is radius. Now we need to calculate ip. We know that ip can be calculated by I think this way. Since these are two same sides, so it's an isosceles triangle. So what we can do is we can simply calculate. They have, I think, mentioned this is 30 degree. So correspondingly, if you use geometry, simple geometry, this is also 30 degree, this is also 30 degree. So this is r cos 30 degree, this is r cos 30 degree, that is equal to 2 into r cos 30 degree. So therefore ip is equal to 2 r cos 30 degree. So just put here vp is equal to v into vp is equal to v into ip divided by io is r. So io is r, and this is root 3r, that I think we have calculated. 2 into oi into cos 30, that is root 3r. So if you put it, you will get vp, velocity at the point p, is equal to square root of 3v. This is the answer. Now question number 34. Consider a truss PQR loaded. So let me write this. Answer is square root of 3v. Question number 34. Consider a truss PQR loaded at a point P. The force F as shown in the figure. The tension in the member QR is. Okay. So what we will do is we will tension the member QR. So what we will do is we will let us consider the point P. What are the forces that are acting in order to make it a static? So if you observe, you will find this F PQ is acting in this way, PR is acting in this way, and PF is acting in this way, downward. So using sine theta and all, what we can calculate is PFQ, F of PQ in the PQ in the truss, in the bar PQ, we can calculate the force that is acting. So F PQ is equal to 0.8965 F. Okay, now this QR, this QR is actually at this point you will find that this particular hinge will resist both horizontal reaction as well as vertical reaction. That means if we dissociate this particular force with respect to horizontal, we will get how much resistance it is, this rod is it is having, how much force that is acting on QR. So the force on QR is equal to F PQ cos 45. So just put the formula and you will get FQR is equal to 0.63 F. So answer is 0.63 F. Question number 35. The natural frequency of the spring mass system shown in the figure is closest to. So in order to find it, you see there are two springs. It may look that it is acting in a series, but actually they all are acting in parallel. Why? The force, rather if you observe it, the deflection that is undergoing is same in both these springs. How? When I say deflection, that is the amount at which the spring 1, suppose this is a spring 1 and spring 2, the amount with which spring 1 is elongating, it is the same amount with which this spring 2 is contracting. So if the elongation is the elongation or the deflection is same in the system of spring, they are said to be in parallel. If it is parallel, it is the net spring force is equal to K1 plus K2. So in this case, 4600 plus 1600, that is equal to 5600 Newton per meter is the net K. So just put the formula and you will get and we know that they have given answer in terms of hertz. So hertz means cycles per second. So generally omega, remember this, you might find confusion. Omega is equal to square root of K equivalent by AM equivalent. But when it comes to frequency, it is called cyclic frequency, that is radians per second. But when it comes to frequency, we say 2 pi into square root of K by M equivalent. Its unit is hertz. They have asked this one, that is 1 by 2 pi square root of K equivalent by M equivalent, that is equal to Fn is equal to 10.06 hertz. Now question number 36, a rod PQ of length L and flexural rigidity EI is hinged at both the ends. So they have asked the question based on hinged, both end hinged. So at for what minimum force F is expected to buckle? So what we will do is, you just decompose this F in terms of in this with respect to this axis. Basically it is a question of changed axis. So F, if I decompose, I will find this is F, say F sin theta, this is F cos theta. So this is F cos theta, say. Anyway, it's 45 degree, doesn't make any sense what we are doing. So this F is acting in the axis of the shaft or the rod, or rod PQ. So for what minimum force F is expected to buckle? Now, I know that F by root 2 must be greater than equal to pi e square pi square EI by LE square. Now we know that for hinged beam, we have the L effective for hinged beam. L effective is equal to L by root 2. Okay, so it's actually for hinged beam, L equivalent, that is L equivalent is equal to L. So just put it here. And what about the force? This square root of 2 will go upward, that is root 2 into pi square EI by L square. So this is the answer. F should be greater than equal to square root of 2 pi square EI L square. So answer is square root of 2 pi square EI by L square is the answer. Now question number 37. What is the minimum force? Okay. Now question number 37. Okay. Question number 37. It's a very simple question. It may look like that it is a CAM question, but actually it is not. It's a simple mathematics question. In CAM design, the rise of motion is given by a simple harmonic motion. Basically, they have shown the distance with respect to the height and all, where h is the total rise, theta is the camshaft angle, beta is the total angle of the rise interval, j is the jerk. So the jerk is given by, jerk we know that it is d cube by d cube s by dt square dt cube. That means this something called, when we calculate velocity is equal to ds by dt, acceleration is equal to d square s by dt square. Then comes the jerk is equal to d cube s by dt cube. Okay, so v is equal to ds by dt, this is velocity, acceleration is equal to d square s by dt square, and j is equal to d cube s by dt cube. So you differentiate it thrice in order to get the value of jerk. Question number 38. A uniform rod of mass m and a length L is equal to 1 meter is hinged at its center and laterally supported one end by a spring of mass spring constant K is equal to 300 Newton per meter. The natural frequency omega in radians per second is. You see here, this is the scenario that they have given. What I will do is, I will get a small theta in this direction. We know that the inertia always acts opposite to the direction of motion. So this black one represents the inertia direction. Okay. Now, what I will do is, I will take moment about O, this point O is equal to 0, and I will write I will balance the moments. That is I theta double dot plus K into L by 2 sin theta. L by 2 sin theta, because this is the force that is acting, L by 2 sin theta into L by 2 is equal to 0. That means m L square by 12, because point to be taken here, we are taking about the center, right? So about the center, what is the moment of inertia about center of the rod? It is ml square by 12, then k l square by 4 theta. Since theta is very small, so I can reduce sine theta to theta. So is equal to 0. I have not mentioned equal to 0 anywhere. It is equal to 0 because moment should be equal to 0. So from here we get k, this is k equivalent and this is m mass equivalent. So from there, square root of kl square by 4 divided by ml square by 12. So if you solve it, you will get the omega n value. Omega n is equal to 30 rads per second. So question number 39. A compression spring is made up of wire, music wire of diameter 2 mm, having shear strength and shear modulus. Shear strength 800 megapascal and shear modulus 80, that is G is equal to 80 GPa. The mean coil diameter is 20 mm and free length is 40 mm. And the number of active coils is 10. Now, if the mean coil diameter is reduced to 10 mm, the stiffness of the spring is approximately. So we know that stiffness of the spring is given by this formula. K is equal to G d to the power of 4. D is the wire diameter divided by 8 into W, that is load. Capital D means the coil diameter, cube into N. N is the number of turns. So here what they did is they reduced the diameter. See, the mean coil diameter is 20 mm and the mean coil diameter is reduced from 20 mm to 10 mm. So mean coil diameter has been reduced from 20 mm to 10 mm. So D1 has been reduced to 20 mm to 10 mm. Is there anything that they have reduced? Now you see the coil's diameter is 10, they haven't changed. Free length they haven't changed. Then nothing else have been changed. See, the wire diameter has been same. G, the shear modulus is same. So that means we can say K is inversely proportional to dq, that is K1 by K2 is equal to d2 by d1 cube, that is K1 by K2 is equal to 1 by 8. That means that the new stiffness, I think the stiffness of the spring is approximately. So now the stiffness is nearly 8 times the previous one, that is increased by 8 times. Answer is 8. Answer is D, that is increased by 8 times. And the previous one I haven't marked the, it's 30. Yeah, I have marked it. What about this one? Minus h by 2 pi dq. Option D. I have not marked that answer, so I am marking it. Anyways, it is increased 8 times. Now question number 40. A journal bearing has a shaft diameter of 40 mm and length and diameter both of 40 mm. The shaft is rotating at 20 rads per second and viscosity of the lubricant is 20 millipascal second. The clearance is 0.02 mm. The loss of the torque due to viscosity of the lubricant is, okay, the loss of the torque, that means we have to find the torque. Okay, so this torque is nothing but shear force into the radius. Now F of the shear force divided by the bearing area. Here comes the issue. You see, in the previous question, if you have seen, I think 2007 question, when we are solving, we were finding Summerfield number where the bearing pressure, remember bearing pressure is force divided by the projected area. But if you see here, this shaft is actually circulated by the lubricant. Okay, so what will be the area? The area where the entire torque will be acting, it will be acting the entire area. Okay, it will so that is the entire circumferential area. So here the area will be pi into d into L. So here diameter they have given 40 and shaft length is given 40, that is 40 into 40. Therefore it is pi into 1610 power of minus 3, that is equal to mu. Okay, so we can say, right, this is shear stress. Shear stress is equal to mu du by dy. This is Newton's law of viscosity, Newton's law. Shear stress is equal to mu du by dy. And what is shear stress? Force shear divided by the it's not bearing area actually, no, it is the rather we can say circumferential area. area. Bearing area is something different. Circumferential area means the circumference of the shaft is completely surrounded by the viscous fluid. Okay, so this the shear force is acting across the circumferential area, that is pi into d into l. D is 40 and l is 40, so 1600 10 power of minus 3 is equal to mu du by dy. So they have given, I think, they have given omega into r is nothing but the viscosity, that is 20 into this radius. I think they have given diameter is 40 mm, radius will be 20 mm. Okay, and dy is the radial clearance. You see clearance they have given, it is actually radial clearance, that is 0.02 mm. So just put it and you will get the force of shear. Once you get the force of shear, now we need to calculate the torque. How will calculate the torque? Force of shear into radius gives the torque value. So what is radius? That is, I think, 40 mm. So that is equal to 0.02 is the radius in terms of meter. So the torque will be 0.04 Newton meter. So the important concept here was, we are not taking bearing area. Okay, bearing area is actually only valid for when we calculate the Summerfield number for bearings. But here when we are calculating the shear stress, we are actually looking the circumferential area where the entire viscosity is coming into picture. Now question number 41. A clutch has an outer diameter and an inner diameter of 100 mm and 40 mm respectively. Assuming uniform pressure of 2 megapascal and coefficient of friction at the inner lining is 0.4, the torque carrying capacity of the clutch is. Now we know, I think in the previous few years question I have explicitly solved how to derive the expression for the uniform pressure. So here also we will see, in this case they have asked the torque carrying capacity of the clutch is. So in a uniform pressure theory, pressure induced is constant. Okay, uniform pressure means you have brought a newly brake. So the pressure that is applying across the surface area of the brake is constant. So pressure induced is constant. Now what is the pressure induced? It is the load, that is W divided by pi into R outer R square minus R inner square. Now what is W max is equal to pi into R outer square minus R inner square into P permissible. I think we have already solved how TF is equal to 2 by 3 mu R0 cube minus RI cube divided by R0 square minus RI square. So from here you get TF value, and what is the power loss? From here you derive the power loss, that is T into omega, and then what is shear stress permissible for this? It is equal to pi into 2 pi RI. These are the formulas that you come across, but I think I have already derived till this. Till this point I have already derived in the previous year questions. Okay, now we will come to our question. We have to calculate the torque, loss of torque. So we know that W max is equal to pi by 4 d outer square minus di square into P max. So this is the W max, that is, this is the maximum load that we can put. From here we can calculate the torque. Then that is what they have asked. T is equal to 2 by 3 mu W R0 cube minus RI cube divided by R0 square minus RI square. So if you put it, you will get the value of torque, that is 196.035 Newton meter. I again reiterate, calculator is a most important ingredient of for preparation, gate preparation. Please solve these questions in the gate calculator, because it may look very simple, just put the formula and get the answer, but actually when we solve in the gate calculator, it is very cumbersome job, because we exclusively use the functions here: MR, memory save, and memory clear. These please get mastery over these three functions: memory read, memory save, and memory clear. Now coming to question number 42. A spur here has a module 3 mm, number of teeth is 16, face width is 36, and pressure angle is 20 degree. It is transmitting a power of 3 kilowatt at 20 revolutions per second. Taking the velocity factor 1.5 and form factor 0.3, the stress in the gear tooth is about. So what they have given here is, they have given all the parameters. Now we have to find the stress at the gear tooth. Okay, so for this, please remember this formula: Ft max, the tangential force max, into the velocity factor Cv into S. The S is the service factor, is equal to B, that is width, M is the module, Y is the Lewis form factor, and sigma permissible is the permissible stress that is acting here. Okay, so here whenever you come across these type of scenario, you will see that the gear is actually taken as a cantilever beam. Okay, it may look like a non-uniform cantilever but we assume it to be a cantilever beam. So based on that we come we solve this question. So this is the formula that you need to remember. This is the entire formula that you need to regarding whenever you found these type of question regarding related to Lewis form factor and all. Okay, now they have given power is equal to 300 kilowatt. Now power is nothing but torque into omega. Okay, so from here we can calculate the torque. 303 kilowatt, that is 3000 is equal to T into omega. From here you get the T. Okay, now what is T? Torque is nothing but Ft into R. Okay, from here you get the value of Ft. Okay, so from here you get the value of Ft. Now just put it in the previous formula, the first formula that you have seen. Ft max into Cv into S is equal to B M Y sigma Y. I think they have already given velocity factor. Velocity factor Cv is equal to 1.5. Service factor they have not given, so we will take it 1. Form factor, that is why they have given Lewis form factor is equal to 0.3. If they have not given, then we have to assume it, or we have to calculate it with this formula. T square by 6 hm is a simple formula for that. Then m is the modular, b is the width. So just put it here. Ft into Cv, Cs they have not given, so we will take Cs as 1. Sigma b into y into b into m. Y is the Lewis form factor, b is the width, m is the module. So if you put it, you will get the corresponding stress in the beam. Of course, it's a bending stress that is acting at the gear 2. So sigma b is equal to 46.04 megapascal. So this is the answer. Now question number 43. I think once I have told you that I will be in one of the in one of the question paper, I will be giving you the exact solution for sorry, I will describe you the entire how the gear is look like and what is their functions and all those things. Okay, so this is the question paper. I think GATE 2008. I will be describing it all. So question number 43. Match the type of gear with the most appropriate description. So helical gear. So look at the helical gear. The teeth of the helical gear are cut at an angle to the face of the gear. So with respect to the horizontal, the teeth are cut at an angle. It a gradual engagement makes the helical gear operate more smoothly and quietly than the spur gears. One interesting thing about the helical gear is that if the angle of the gear teeth are correct, they are mounted on a perpendicular shafts adjusting the rotation angle by 90 degree. So what main important thing is axis are parallel, axis is parallel and teeth is inclined to the axis. Okay, so helical gear axis parallel, teeth inclined to axis. That means helical gear P is 2. Now now comes spiral bevel gear. Now coming to the spiral bevel gear, you can see here the figure of it. So spiral bevel gear, you can see the figure. The axes are perpendicular. That means the axes are perpendicular and interesting. The axes are perpendicular and intersecting. And the teeth are inclined to the axis. The teeth are inclined to the axis. Yes, the teeth you can see it is inclined to the axis. So spiral bevel gear, axes are perpendicular and teeth are inclined to the axis. Okay. Now hypoid gear, the axes are perpendicular and non-intersecting. Why? Because here the axis is somewhere like this, here the axis is somewhere here, which is not intersecting. So hypoid gear, axes are perpendicular Okay, so axes are perpendicular and they are generally used for large speed reduction. Okay, we can write here also, used for large speed reduction. Okay, now rack and pinion, you see here rack and pinion, the axes are parallel. See here the axis is this is a very infinitely large, means it is a straight line, so we can assume that it is a gear with a infinitely large radius. So the center is same, the axes are parallel. We can take a center there also, the axes are parallel and one of the gear has infinite radius. Okay, so what will be the answer? Rack and pinion, this will be the answer 6. So 2 4 5 6, 2 4 5 6. I'm sorry, it is non-intersecting, right? I think for hypoid gear it is this one. Axes are parallel. No, axes are not parallel, rather axes are perpendicular, are not intersecting. Axes are perpendicular, perpendicular used for large reduction. Helical gear, axis is parallel and teeth is inclined. Spiral gear, axes are perpendicular intersecting. Okay, so P2 Q4, P2 Q4, 1 or 4. R is 1 or 4. R is 1 or 4. Axis perpendicular intersecting and the teeth is inclined to the axis. Teeth is inclined to the axis. Axis is not it is not intersecting. No. Rack and pinion, it's 6. So either A or B, that is R is 1. Axes are non-parallel. Okay, answer is this. R is hypoid. Axes are non-parallel. Okay, so axes are of course perpendicular if we see, but non-intersecting. Axes are non-parallel and intersecting. Okay, so it will be helical gear, axes are parallel and teeth are inclined. Spiral gear, spiral bevel, axes are perpendicular and intersecting and the teeth inclined to the axis. Hypoid gear, axes are non-parallel or perpendicular and non-intersecting. Rack and pinion, axes are parallel and gear has infinite radius. So it will be option A is our answer. So just visualize from this. Okay, now let's move on to question number 44. A gas expands in a frictionless piston cylinder arrangement and the expansion process is very slow and is resisted by an ambient pressure of 100 kilopascal. Okay, that means there is an external atmospheric pressure that is acting. Okay, now during the expansion the pressure in the system is remains constant at 300 kilopascal. The change in the volume is 0.01 meter cube. So the maximum amount of work that could be utilized in the above process. So what is the maximum amount of work that we can utilize? So you see here there are two types of pressure, that is internal pressure that is acting, okay, and there is an external, that is the external pressure, that is atmospheric pressure is acting. Okay, so what is the difference of this pressure? So whenever the gas is tends to work, that means the system is working. So what we will see here is it will be because of the difference of this pressure. Therefore the work will be 300 minus 100 into the change in volume. Okay, so very soon you will find GATE 2007 question being uploaded. So I am right now uploading the GATE 2007 question. Just give me 1 sec. Just give me 1 sec. Okay, so it's 2 kilojoule. Answer is 2 kilojoule. Okay, now question number 45th. A logarithmic mean temperature difference LMTD of a counter flow heat exchanger is 20 degrees centigrade. The cold fluid enters at 20 degrees centigrade and hot fluid enters at 100 degrees centigrade. Mass flow rate of the cold fluid is twice that of hot fluid. So specific heat at a constant pressure of a hot fluid is twice that of cold fluid. The exit temperature of the cold fluid is. So what they have given is this. They have given this type of scenario. Mass of cold fluid is twice the hot fluid and mass of cold fluid is specific heat of cold fluid is half of the hot fluid. So if I find mc into cc, we get the same value. That means mc into cc is equal to mh into ch. That means, so in the I think in the previous gate question paper, that is 2007, they have generated a similar scenario where they have given the specific heat. The specific heat mc into cc is equal to mh into ch. So what will be the lmtd for that? So lmtd will be same, because it may act as counter, but the actual diagram that you can feed, the actual diagram will be something like this. And that means at any point of time across the length, the temperature difference will be almost same. So here the temperature difference was, let me see. You see, the cold enters 20 degree, hot fluid enters 100 degree. Okay, counter flow, lmtd is 20. Okay, so the lmtd is 20. That means the temperature difference will be, the temperature difference here will be 20. That means here it will be 80 and here there will be 40. So what is the th exit? Th exit. Okay, so it will be I think delta T is equal to 20, right? 20 plus th exit will be 40. It will be, answer is 40 degrees. Okay, I'm sorry, I by mistakenly written here, because this delta will be same as this delta. Okay, let me reconfirm. Let me recheck. The mass fluid now specific heat. The logarithmic will temperature, the counter fluid is 20 degrees. Cold fluid enters 20 degrees and hot fluid enters 100 degree. Okay, the mass flow rate of the cold fluid twice itna, the specific heat itna. The exit temperature of the cold fluid is the exit temperature of cold fluid they have. I'm sorry, exit temperature of the cold fluid they have asked. So what is the exit temperature? Simple. I think the calculation, it's simple, right? The delta T is same, 20 degrees, right? So 100 minus 80 minus 20 is 80. And what will be the exit temperature of hot fluid? It is same 20. So it will be 20 plus 20, that is 40 degrees centigrade. So this, since they have asked about the cold fluid, so answer will be, as I have already calculated, cold fluid, it will be 80 degrees centigrade. Okay, so I hope you can observe how the questions they have asking on a same topic, on a same concept, they are just twisting it from the previous year question. Okay, now question number 46. One dimensional fluid element rotates about a rigid body at a point within the element. The pressure is 1 unit. The radius of the Mohr circle characterizing the state of stress at that point is. Again repeating, a two-dimensional fluid element rotates like a rigid body at a point within the element. The pressure of 1 unit, the radius of the Mohr circle. So what actually they is saying is, the fluid element rotates about rigid body at a point within the element. The pressure is 1 unit. Okay, so here it has been visualized in this way. The pressure is the pressure is 1 unit. Okay, that means sigma, as I told you already that pressure is always the pressure is always acting in a compressive way. Okay, so sigma x is equal to sigma y is equal to -1. Now tau, so what they have asked, they have asked the Mohr circle, right? The Mohr circle will be square root of sigma x minus sigma y by 2 whole square plus tau xy square. So tau they have not mentioned, so it will be by default 0. Since tau xy is equal to tau, tau x is equal to tau y in terms of magnitude also, so here the radius will be 0. That means it represents a dot, a point in the negative x-axis of the Mohr's, in the coordinate rather. Okay, so what about the radius? The radius will be 0. For a point, the radius will be 0. Now question number 47. A cyclic device operates between the 3 thermal reservoirs shown in the figure. The heat is transferred to form cyclic device. It is assumed that the heat transfer between each thermal reservoir and a cyclic device takes place across negligible temperature difference. Interaction between the cyclic device and respective thermal reservoirs are shown in the figure in the form of heat the device is. Now, if you observe carefully from where the heat is coming, it is coming from something called higher, right? 1000 is the highest temperature, 500 is the second highest, and 300 is the lowest temperature. Okay, now that means that the heat is coming from those higher temperature and going towards a lower temperature. What this actually the device is? Definitely it's a heat engine. Now we have to identify whether it is reversible or not. That means option A is correct, option C can be correct, option A or option C. So we need to now check whether it's a reversible or reversible. So for that, what we need to do, we need to check cyclic integral of del q by t is equal to what. If it is less than 0, that means irreversible. If it is equal to 0, it is reversible. If it is greater than 0, which is impossible. So just put it, that means 1000 kg is giving away the heat, that is minus 100 kilojoule divided by 1000, then 50 kilojoule is getting away from the system, that it is minus actually, I'm sorry. It is minus because 50 kilojoule is extracted from 500 kilojoule. So 50 divided by 500 again. Then 300 is accepting, that is therefore it will be plus. It will plus. It will plus, it will minus. When you solve it, you will get it is 0. That means it's a reversible heat engine. So answer is reversible heat engine. Question number 48. A balloon containing ideal gas is initially kept at an evacuated and insulated room. The balloon ruptures and the gas fill up in the entire room. Which of the following statement is true at the end of the process? Internal energy of the gas decreases from its initial value, but enthalpy remains constant. Internal energy of the gas increases from its initial value, but enthalpy remains constant. Both internal and enthalpy remains constant. Both internal energy and enthalpy of the gas. It's a very beautiful question. So in an insulated room, that means, and since we are rupturing, that means we are experiencing free expansion. That means it is insulated, del q is equal to 0. There is no change in, there is no exchange of heat. Del w is equal to 0 because of free expansion. That means by the first law, we know that del q is equal to, remember this, I have already told you, del q, whenever you write the first law, please write del q is equal to du plus del w, because del q and del w represents the path functions. So therefore they should be subscripted. The subscript will be del, not d. This is a point function. So if this is 0 and this is 0, that means by default du will be 0. Okay, du, that is cv dt is equal to 0. That is temperature remains constant. Now when the temperature remains constant, what about enthalpy? How the enthalpy is calculated? Enthalpy is calculated Cp into delta T. Okay, now when we already told that dt is same, dt is 0, that means Cp dt is also equal to 0, that is enthalpy is also is equal to 0. Therefore both internal energy and enthalpy of the gas remains same. Why? Because the change in internal energy as well as change in enthalpy is 0. Now question number 49. A rigid insulated tank is initially evacuated. The tank is connected with a supply line through air assumed to be ideal gas with a constant specific heat, passes at 1 megapascal at 350 degrees centigrade. A valve connected with the supply line is opened and the tank is charged with air until the final pressure inside the tank reaches 1 megapascal. So the final temperature inside the tank is, okay. So initially the tank is evacuated. When the evacuation tank is, we are filling it, that means del W is equal to 0. Okay. Now, since it's insulated tank, here also del Q will be 0. Okay. So this rigid, for the rigid tank, del W is equal to 0, del W is equal to 0, del Q is equal to 0. Okay. Now, this at least we know, looking at the question, we know this. So initially this pipeline has 1 megapascal. This pipeline has 1 megapascal and 350 degrees centigrade. So P1 is equal to 1 megapascal, T1 is equal to 623 Kelvin. Okay. Now applying unsteady flow of equation, that means del Q is equal to Mi, that is mass initially entering, is equal to H1 plus Ci square, Hi plus Ci square by 2000 plus Gzi by 1000 is equal to del W plus M out, H0 plus C2 square by 2000 plus Gz2 by 1000. Now, since Q is equal to 0, del W is 0, as we have already told. What is this H? H is equal to U0 plus P PV. We know that H is equal to PV. That means, but they have, is there anything mentioned initially? It's insulated, initially evacuated. That means in the tank there is no pressure at all. That means P0 is 0. If P0 is 0, that means H0 is equal to U0. Okay. So this entire term is 0. This entire term is 0. Only thing that is left is H0. We have to evaluate only and only this particular portion, that is H0. They have not mentioned any mass here. So H0 is equal to U0 plus PV. Since this is evacuated tank, that is there was nothing at all. So the pressure will be definitely 0. So when the pressure will be 0, the only thing is H0 is equal to U0. Now, is there given anything about the U0? So just put it, MHI is equal to MEU. That means initially whatever value they have given, that means here it was MHI, here it was MH0. So H0 will be converted into U0 format. So I can say H0 MI HI is equal to M exit U. Okay. So that means CP T initial is equal to CV T final. That is T final is equal to CP by CV T initial. So in this case, TF is equal to gamma into Ti. Therefore, final temperature, since gamma is greater than 1, so final temperature will be 1.5 into 623 Kelvin. So from here, if you calculate, it will be 872.2 Kelvin, that is greater than 350 degrees centigrade. So answer will be, it will be greater than 350 degrees centigrade. Okay. So if you reiterate this question, you will find that there are two systems here. It's a question of unsteady flow equation. So we will apply the SFEE curve. Okay. And we find that since in the second case, especially here, there is, let me re-explain you once again. So in the second, that is in the evacuated tank, there is no pressure at all, that is completely evacuated. So this H0 will be converted into U0 only because the pressure itself is 0. Now the tank is already contained to be insulated and evacuated. So del W and del Q is by default 0. Del W is 0 because of sudden expansion, because it is evacuated. So del W is equal to 0, del Q is equal to 0. C1, C2, they have not mentioned anything. We will intentionally take it 0. So finally I will left is MI HI is equal to M out, rather MO, not MO into, that is mass in the tank, final mass of the tank and initial mass at the air supply line. Mi into HI is equal to Mo into UO. Now they have not mentioned anything about mass, so we will simply cancel it away. The only thing that is left is Hi is equal to, that means whenever this type of question comes, just remember one thing. This is a very special case where enthalpy will be equal to internal energy in this particular case. Okay. So TF will be equal to Cp by Cv into Ti. That means final temperature will be 1.4 times that of initial temperature. That is equal to 873.2 Kelvin, which is greater than 350. So this is what they have given, greater than 350 degrees centigrade. Question number 50. For a three-dimensional object shown in the figure below, 5 faces are insulated. The sixth face, PQRS, is not insulated. Interacts thermally with the ambient with a convective heat transfer coefficient 10 watt per meter square Kelvin. Ambient temperature is 30 degree and the heat is uniformly generated inside the object at the rate of 100 watt per meter cube. That means whatever the internal energy it has, the same thing it will be giving out. Okay. So since PQRS, that means the non-insulated portion, is maintained at a constant temperature. That actually means the heat is traveling at a steady rate. That means whatever energy that is being extracted, the internal energy of the system is throwing out of the system through PQRS wall at a very uniform rate. Therefore, it has been equated. Q generated into the volume is equal to M, I think, Ka delta T. I think K has been given, right? 10 watt per meter square A into delta T. So from here you can calculate the, I think they have asked the steady state temperature is 40 degrees centigrade. Okay. Now question number 51. The water having a density of 1000 kg per meter cube issued from the nozzle with a velocity of 10 meter per second, and a jet strikes a bucket mounted on a Pelton wheel. the wheel rotates at 10 radians per second. Okay, the wheel is rotating at a 10 radian per second. So from here, what we can calculate? We calculate the velocity, that is pi d n by 60, pi d n rather, because they have already given in radians per second. The mean diameter of the wheel is 1 meter. The jet splits into two equal streams by the bucket, such that each stream is deflected by an angle 120 degree. The friction in the bucket may be neglected. Okay, the friction of the bucket may be neglected. The magnitude of the torque exerted. Now, what is torque? Torque is nothing but force into R. Now, here we have to first calculate the force, then multiply R, and we can get the corresponding torque. So, you see here, what is the velocity of wheel? As I have told you, it was omega into R. You can get 5 meter per second easily. What is jet velocity? Jet velocity is 10. Now, what is the relative velocity? It is 10 minus 5 meter per second, because jet is also going in this way, and the wheel, they have not mentioned though, but still wheel is also going in this way. Okay, yeah, wheel also is going in this way only. Okay, now what is our relative velocity? It is 5 meter per second. Force, we know that mass into, that is nothing, force is nothing but the change in momentum, right? So mass into initial velocity minus exit velocity. Why initial velocity minus exit velocity? Because if you go initial velocity minus exit will give you a positive force, otherwise it will give a negative force. It will, in order to, because ultimately the velocity is going to reduce when it go through the bladings. Okay, it is not going to increase. So what we will do, first initial mass. What is mass they have given? Have they given anything related to mass? Yes, they have given mass. I'm sorry. The torque exerted wheel per unit mass. If they have not given torque per unit mass, then we would have been taken mass is equal to rho into area into V. That is equal to mass density into area into velocity. So mass into area into velocity would have, sorry, density into area into velocity would have been taken. But since they have already mentioned per unit mass, so we don't have to bother about it. We can simply, for our understanding, we can write force is equal to mass into inlet velocity by exit velocity. So we can simply put it here, force by mass, that is force per unit mass is equal to inlet velocity. What is the inlet velocity? Inlet velocity will be this relative velocity. 10 minus 5, because bucket is also moving and jet is also moving in the same direction, so the relative velocity 5. Now what about the exit velocity? If you see here, if you observe it carefully, the exit velocity will be in opposite direction. Opposite direction, it has two components. Since they have given in the figure 120 degree deflected jet, so it will possess two components, first in horizontal direction but in opposite, and in a vertical component in upside. The only component that will be taking care of is the horizontal component. Okay, so it will be minus 5 cos 60 degree. Okay, because the direction is opposite. Minus cos 60 degree, that is equal to 7.5 Newton per kg per second. Okay, now you have to calculate the torque. Simple, force per unit mass into, actually this is torque per unit mass. Torque per unit mass is equal to force per unit mass into radius. Just multiply it by the radius. So what is radius? Diameter of the wheel is 1 meter, so radius will be 0.5 meter. That is equal to 3.75 Newton meter kg per second. I hope it is understood. We will not multiply this particular 10. I think they have given, right, 10, this one, jet. We will not do that, because wheel is also rotating in that direction. Okay, that means the tangential velocity of the wheel will be in this direction. Also the jet is also moving with this direction, so we will be using relative velocity concept. Okay, that is equal to 5 meter per second. Again we will be considering, while calculating the exit velocity, we will be considering only the opposite horizontal velocity that is coming into picture. That is why minus of minus will become plus, and it becomes 7.5 Newton per kg second, and henceforth the torque can be calculated, which is 3.75. So answer is 3.75 Newton meter per kg second. Now question number 52. A thermal power plant operates in a regenerative cycle with a single open feed water heater. For the state points shown, the specific enthalpy H1 is equal to 2800, that is 2800 kilojoule per kg. H2 is equal to 200 kilojoule per kg. The bleed of the feed water heater is bleed to the feed water heater is 200%. 20% of the boiler steam generation rate. So the specific enthalpy at the state 3 is. So we have to find specific enthalpy at 3. Okay, that means 20%. That means the feed water heater is throwing up to 20%. That means whatever steam has been expanded through the turbine, 20% of it is going to the feed water, and rest 80% is going to the, it is expanding to the condenser. Okay, which is at, I think, open water H2 they have mentioned 200. Okay, I've already marked here H2. So 80% of the mass of the steam is getting expanded to the condensate extraction pump, rather through condenser it is coming to the feed water, and 20% of the steam is actually 20% of the steam is actually going to the feed water for regeneration purpose. We have to calculate the H2 here, I think H3 rather. We have to calculate the specific enthalpy of 3. So specific enthalpy of the 3, H3 is equal to 0.2 into 2800 and 0.8 into 200. Just add it up and you will get H3 is equal to 0.8 into H2 plus 0.8 into H1. Just add it up and you will get the corresponding answer of H3, the value of H3. Okay, so H3 is equal to 720, I can give kilojoule per kg. Kilojoule per kg is our answer. So let us see question number 53. A moist air at a pressure of 100 kilopascal is compressed to 500 kilopascal and then cooled to 35 degrees centigrade in a aftercooler. The air at the entry of the aftercooler is unsaturated and becomes just saturated at the exit of the aftercooler. The saturation pressure of the water is 35 degrees at 35 degrees centigrade is 5.628 kilopascal. The partial pressure of the water vapor in kilopascal in the moist air entering the compressor is closest to. So basically the scenario is the moist air of 100 kilo is compressed. Basically the moist air is entering into the compressor from 100 kilopascal to 500 kilopascal and then cooled to 35. So there is aftercooler here, aftercooler, and then cooled to 35 degree. Here it is 35 degrees centigrade in an aftercooler. The air at the entry of the aftercooler is unsaturated. Here it is unsaturated and become just saturated at the exit. Here it is saturated. Here the air becomes saturated. The saturation pressure of the water at 35 degrees centigrade. Saturation pressure. So here it is saturated and the pressure is actually here. It is means the water, the saturation pressure of water at 35. Basically the air is having 35 degree but the water vapor present inside it is saturated, that is 5.628 kilopascal. So the partial pressure of the water vapor in kilopascal in the moist air entering. So they are asking partial pressure of the water vapor of the moist air entering the compressor. Okay, so they are asking what is the partial pressure here and they have given saturated saturated pressure at this point. Okay, so what we will do here is, see, since the moisture is saturated at this stage it is saturated, so final compressed pressure is how much? That is 500 kilopascal. So we see omega, we know that omega is kilogram of water vapor, kgs of water vapor, rather we can say kg of water vapor per kg of dry air. Omega is equal to 0.622 PV saturated divided by P minus P saturated, V saturated, right? Okay, so at this point what will be the omega here? So PV here is actually 5.35. Here they have mentioned, right, PV is equal to 2.628 5.628. At this point, what is omega at omega at the aftercooler? That is omega after cooler is equal to 0.622 into 5.628 divided by, because here the pressure was 500 kilopascal, right? So near the after cooler, so here because pressure will be almost same after the after cooler, means whenever it will go inside after cooler the pressure will remain same, the same 500 kilopascal. So that will be 500 minus 5.628. So omega after the after cooler is this much, that is 7.083 into 10 power of minus 3 kg of water vapor per kg of dry air. Dry air. Now what about the pressure at what about the PV? Rather, they have asked partial pressure of water vapor when it is entering the compressor. That means the water attains saturated pressure. That means the water has not been drifted off in the after cooler. The water content is same. Now we have got right this. We have already received that the water content in the air was, so omega is equal to 7.08 into 10 power of minus 3. That was already present. It has not been drifted out. Now we will use the same formula, and keeping P atmospheric is equal to 100. So omega is equal to 0.622 PV inlet. That means at the compressor inlet it will be PV inlet divided by 100 minus PV inlet. So if you solve it, you will get pressure of the vapor. Remember, pressure of the water vapor at the inlet will be 1.13 kilopascal. I hope you understood. So the main concept behind it is, in the intercooler, means from the compressor, the air from inside the compressor to the exit of the intercooler, there is no drifting out of the water vapor. Okay, the content of the water vapor remains same. So we first calculated the amount of water, that is specific humidity of the water vapor at the exit of intercooler, and through this we found the amount of water vapor that is present per kg of dry air, and utilize the same thing at the entry of the compressor. From here we get the partial pressure of water vapor at the entry of the compressor. Now question number 54. A hollow cylinder is formed between the two infinitely large concentric cylinders of radii 1 meter and 2 meter. Okay, the radii here, the radius is 1 meter and here the radius is 2 meter. Because radiative heat exchange takes place between inner surface and the larger cylinder, surface 2. So inner surface is surface 1, outer surface is surface 2. The radiating surface are diffuse and the medium to the enclosure of is non-participating. Okay, so the fraction of thermal radiation leaving the larger surface and striking itself. That means we want to find F22. Basically, it means that only. So I made a schematic diagram here. That means the inner cylinder is completely surrounded by the outer cylinder. Okay, so that means we have already assigned the inner cylinder as 1 and outer cylinder as 2. That means 1 of 1 is so F of 1 that means the radiation that is getting out of the cylinder 1 and striking itself will be 0, because all the radiations will be absorbed by the or rather strike the surface 2. So F11 will 0. By default, what we get, we know that F11 plus F12 is equal to 1. So by default we get F12 is equal to 1, and we all know the reciprocatory theorem, that is F12 into A1 is equal to F21 into A2. From here we get F21 is equal to A1 into A2. Now since they have talked about the length, assume that they both belongs to same length, right? So that is pi dl, pi A1 by A2 is equal to pi D1L divided by pi D2L. So from here we get D1 by D2, that is F21 is equal to D1 by D2. Now what is D1 by D2? D1 by D2 they have mentioned, right? What is the radius? Yes, that is equal to R1 by R2. So that is 1 by 2. That means F21 is equal to 1 by 2. Now I know that F21 plus F22 is equal to 1. Okay, so I got F21. So from here I can calculate F22, that is equal to 0.5. This is the answer. Question number 55. Air at atmospheric pressure of dry bulb temperature 40 degrees centigrade and wet bulb temperature 20 degrees centigrade is humidified in an air washer operating with a continuous water recirculation. The wet bulb depression, that is difference between dry bulb and wet bulb temperature at the exit is 25% of the inlet at 25% of that at inlet. Okay, that means at the inlet, whatever may be the wet bulb depression, the at exit it will be 25% of that inlet. Okay, that means wet bulb depression at the inlet will be 0.25% of the wet depression. Actually, there is something wrong here. Wet bulb depression at the inlet of inlet, right? So actually I've made so small mistake. Actually it should be at outlet is equal to 25% of that inlet. Okay. Okay, so I will assign it in the way, that means wet bulb temperature at the inlet. So if I look the data that is given here, that the air atmosphere with dry bulb temperature 40 and wet bulb temperature. So at the inlet it is 40 minus 20 of 0.25. Then what is the dry bulb temperature? That is T dry at the outlet minus what is wet bulb temperature. The wet bulb temperature, okay, the wet bulb temperature is, so you have to have dry bulb temperature at the exit of water is closest to. I think wet bulb temperature will remain same. Wet bulb temperature will remain same. Okay, because wet bulb temperature for any air will always remain same. So T of dry minus 20 degree is equal to 1 by 4 of 20, that is equal to 5. T of the, that is here it is exit. Here it is exit. So D of dry is equal to 20 plus 5, 25 degree centigrade. I made a small mistake because I made opposite to it. So wet bulb depression of the outlet is equal to wet bulb depression of the inlet. 25% of the wet bulb depression of the inlet. Wet bulb depression, so wet bulb of any air is always remain same. Okay, because it's a constant quantity for any given fixed quantity of air. Okay, they have not changed the system. The air that they have introduced, they have not changed. So wet bulb temperature remains same, and so T dry at the exit, T dry minus 20 at exit is equal to 25% of that wet bulb depression of the inlet, and if you subtract it, you will get the same answer, that is 25. Let me check if it is 25. Yes, it is 25 degrees. 25 degrees centigrade is the answer. Okay, so here the what is the concept here? Here the concept is the wet bulb temperature for a particular system does not change. Now question number 56. Question number 56. A steady two-dimensional heat conduction takes place in a body shown in the figure below. Normal temperature gradients over the surface P and Q can be considered to be uniform. Temperature gradient dt by dx at a surface Q. dt by dx at a surface Q means that is this way. The temperature is varying with respect to x, dt by dx in this direction at a surface Q is equal to 10 kilowatt per meter. Surface P and Q are maintained at constant temperature as shown in the figure, while remaining part of the boundary is insulated. Okay, the entire boundary, all these boundaries insulated except surface P and except surface Q. The body has a constant thermal conductivity of 0.4 watt per meter Kelvin. Calculate the value of dt del T by del X and del T by del Y. Okay, I think they have already mentioned, right, what is del T by del the temperature gradient at the surface Q. Okay, at the P they want. Okay, now they have said that it's a two-dimensional heat conduction equation. That means suppose here it is going through this way, the heat is going through this way, and here it is getting excited because from all other sides it is insulated. Okay, so heat Q in is equal to Q out. That means I can say Kp, that is thermal conductivity at P into dt by dy is equal to K into dt by dy. Okay, they have also mentioned some data, that is here 2, assuming that the uniform width. Okay, the width is uniform. So Kp into 1 into B into dt by dy at P is equal to Kq into 2 into B dt by dx at Q. So from here, if you find what is Kt by Kx, Kt by Kx have they given? Kt by del T, sorry, let me write it, del T by del X at Q. They have given something, right? It's 10, right? 10. And Kp they have given at Q, Kq is equal to 10. Okay, here you will find 10. This one they have given del T by del X is equal to 10. Okay, now Kp they have given anything. The body has a constant thermal conductivity. Kp is equal to 0.1. Sorry, Kp is equal to Kp is equal to Kp. Kp is equal to Kq. So it will be cancelled away. Okay, the only thing they have given it's 10. Okay, so what is del T by del Y at P is equal to 2 into 10, because B will be cancelled. So this will be 20 Kelvin per meter. Okay, so this is 20 Kelvin per meter. Now del T by del X, now we found del T by del Y. Now if you observe, the heat is taking at P, the heat is taking from this side and it is exiting at this side. That means del T with respect to del Y at Q is equal to del T at del X at P, both will be 0, because since the heat is taking place in this perpendicular to the surface direction, they are not taking in the in any other direction. Okay, so there are two-dimensional heat conduction equation taking place. Only in here it is taking place in this direction, and here it is taking in this direction. That is it. Therefore here there will be no heat conduction. In this place, in this direction, there will be no heat conduction. Therefore del T by del Y is equal to 0. Also del T by del Y at Q is equal to 0, and del T by del X at P is equal to 0. So del T by del Y at P, so at P will be 20, and del T by del X at P is equal to 100. This is additional information, that is del T by del Y at Q is equal to 0. Now question number 57. In a steady state, steady flow process taking place in a device with a single inlet and single outlet, the work done per unit mass flow rate is given by W minus of integration inlet to outlet VdP, where V is the specific volume and P is the pressure. The expression W is given above. So the expression W is given. So since this W expression contains only property, see, as I have already told you that W is nothing but a path function, and with this right hand side is nothing but property. So it is valid for any reversible process. Okay, so it is valid for any reversible process. Question number 58. Now for a standard transport linear program with m sources, n destination, and total supply equating total demand, that is, it's a balanced one. An optimal solution, that is lowest cost with the smallest number of non-zero xij, that is the amount that is required from going from transporting from source I to source j is desired. The best upper bound for this, basically they have asked whether to obtain the degeneracy, what is the condition. So for degeneracy, the number of allocations should be equal to m plus n minus 1. Okay, then only we can proceed the transportation problem in order to attain the Now question number 59, it is m plus n minus 1. Question number so in this question number 59, we can only start the optimization problem once we found that the number of allocated cells is equal to m plus n minus 1. Now question number 59, a moving average system is used for forecasting weekly demand F1 of t, F2 of t. F1 of t, F2 of t are in sequence of the forecast with the parameter m1 and m2. m1 is greater than m2. Denote the number of weeks. That means m1 week is greater than m2 number of weeks. With a moving average you are taken. Okay, moving average you might be knowing, right? The moving average means just take the average of the suppose I take 3 weeks or 3 time zones moving average. So I will divide the corresponding forecast or demand and divide it by 3. So these are the example of moving average forecast are taken. Actual demand show in the step, that means actual demand shown in the step increase from D1 to D2. So earlier it was D1 and now it is D2. So at a certain time. Now subsequently, so since the latest demand has more weightage for the F2, the latest demand has a more weightage of the F2, therefore F2 will attain the value of D2 before F1. Okay, so answer will be F2 will attain the value of D2 before F1. So this will be the answer. Okay, because the latest demand has more weightage, because if the because we are, whenever we are taking the moving average, we are taking the latest demands based on the number of months or time period we are considering. Now question number 60. Here they have given a sequence, that is P to Q, Q to G, P to R, R to G. Now we have to find For the network diagram, they have given the objective is to find the length of the shortest path from the node P to G. Okay, so Dij represents the length of the directed and are from node I to J. So let Sj be the shortest path between P to node J. Which of the following equation will be used to find Sj? That means shortest path we need to find to get to Hg, to G, sorry, in order to get G. Which path, which is the shortest path? So we know that PO and PR are same. They have only told with respect to SQ and SR, right? SQ and SR. So whether will we add the duration or we will subtract the duration, that's what they are asking. So the minimum, so the shortest part, the length of the shortest path from P to node J will be, it will be SQ actually. This is SQ, this not SQ, it is SQ. So this is SQ and this is SR. So it will be minimum of SR plus Dij, or the minimum of SR plus Dij and minimum of SQ plus Dij. This is, so in order to achieve the shortest path between P to J, it will be minimum of S plus D Qj or SR plus DRJ. Now question number 61. The product structure on an assembly P is shown in the figure. Estimated demand at the end of P is given here. Week 1, 2, 3, 4, 5, 6. There are 6 weeks. Corresponding demands have been given 1,000, 1,000, 1,000, 1,000, 1,200 and 1,200. This is for the end product P. Okay. Now we have to see, ignore the lead times of the assembly and sub-assembly. The production capacity for the component R is the bottleneck operation. That means the R is a very critical resource. If R stops, means R is actually the place where the maximum hanging is taking place, means maximum time is taking place. Starting from zero inventory, the smallest capacity that will ensure a feasible production plan for 6 weeks is. So basically, since R is the bottleneck capacity, that means since R is the bottleneck capacity, that means we have to calculate the total number of hours that are used to produce this P. So here you will find in the assembly, R is here P is 1000, right? Sorry, we will calculate for each week. 1000 plus 1000 plus 1000 plus 1000, that is 4000. 4000 plus 2400. 4000 plus 2400 is 6400. That means total in an average in 6400, in order to make in 6 weeks we have to make 6400 units of P. So in order to make 6004 units of P, we need 6400 R. Okay, similarly we need 6400 units of Q. Okay, that means in order to produce 6400 units of Q, we need to produce 6004 units of R. So totally, what is the total unit of R that we need? It is 6400 plus 6400. That is equal to, I think, it is 12,800. Now what about Q? It is 6400 required. For S, again, for S we need 6400. Okay, so there are basically Q, S, R are the 3 ingredients that is required to make the product P. But for R, we require 12,800, and they have already mentioned component R is the bottleneck operation. That means R is the place where we are executing maximum time. Okay, so the smallest capacity that will ensure a feasible production plan up to 6 weeks is for 6 weeks. That means we need a total size of R should be 12,800 for 6 weeks. Okay, so what I will do is I will divide, that means production capacity per week for the component R, the production capacity of the component R is the bottleneck operation with zero inventory will ensure. So basically they have, here is the question where you need to think of production capacity per week for the component R. That means we need actually for the smooth operation we need 12,800. Okay, but the question that they ask is production capacity per week for the component of R is the bottleneck operation starting with zero inventory. Smallest capacity that will ensure the feasible production plan up to 6 weeks is. That means this is the total unit that we need for R, and per week how much we need. We will simply divide it by 6. That is 2133.36. 33.3. That is equal to almost, that is somewhat greater we need, because we will keep some sort of a little bit greater. The nearest option is 2200 is the quantity of R we need per week. That means in our stock we need to recur per week 2200. So now let us see question number 62. It's a beautiful question. So it involves huge amount of analytical geometry. It may look very simple at the beginning because it is whatever we have learned in our college. It gives it, this question touches that particular approximation, and if we override or if we go with those approximation, then we will make a mistake. You see, this question has given that a gear at one tooth of the gear make 4 module and 32 teeth as shown in the figure. Assume the gear teeth and the corresponding tooth space make equal intercept on the pitch circumference. The dimension of A and B, if you observe carefully, we can looking, if you look from a general perspective, we will think that B is nearly equal to module. I will simply put it, that means the module is nothing but the space after the addendum. We can see and simply put option A as as our option, but answer is wrong. Why? Because they have not asked the module, they have asked something different. They have, if I zoom it, you will find something like this. Okay, basically what we have read in college is module is this one. Okay, now they have asked this module plus this particular space is B. Okay, and the tooth thickness they have asked. Okay, so here comes, that's why I told in the beginning that this was a very conceptualistic paper because Indian Institute of Science made this. So anyways, each and every line has some significance here. See, one tooth of the gear having 4 module and 32 teeth. So from here we can calculate pitch circle radius. Okay, so anyways, the gear tooth, assume that the gear tooth and the corresponding tooth space make equal intercept of the pitch circle. That means this is my gear tooth, this is my gear tooth, there will be equal interspace, there will equal interspace, and again there will be another gear tooth. Okay, that means 360 degree divided by 32 gear teeth plus 32 tooth spaces will be equal to the angle subtended by these two both. Rather, I can say the angle subtended by the gear tooth will be equal to 360 divided by 32 plus 32, that is equal to 360 divided by 64, let me calculate, it is 5.625 degrees. Okay, now let's see the next page. Let me move on to the next page. That means if you observe, if I take the middle portion, it will be 55.625 divided by 2, that is equal to 2.812. I have taken up to 3 decimal places. 2.812 is the angle that is subtended by this part at the point midpoint of the tooth and this tooth surface. Okay, so now I need to find this portion A, right? So I can say A by 2 divided by this pitch circle radius is equal to sine 2.812. Okay, I know that pitch circle radius is equal to mt by 2. Module they have given, teeth they have given, divide by 2, I will get the pitch circle radius. Therefore, A by 2 is equal to R into sine 2.812. That means total A is equal to R into, that is 2 into R into sine theta, that is equal to R into sine theta multiplied by 2. From here I get the value of A, that is equal to 6.279. So 6.279, that is equal to 6.28. Again, if you see option C and option D, both are correct. Now we have to find B. Just zoom it off. Let me zoom it. You see, we have to find the value of B. That means B will be this M module, because we know that addendum is nothing but equal to module. So M will be there. That means certainly it will be greater than 4 mm. Both the options are more than 4 mm, 4.3 and 4.1. Now we will see here. This is addendum, we know that, and addendum is equal to the size of module. Plus, how I will calculate this particular portion? How I will calculate this particular portion? That is a challenge here. Okay. Now, I know that from a center to this particular point, what is that? This is pitch circle radius. Okay. And this pitch circle radius minus this I need to get. So that means I have replicated the same in here. OQ is the pitch circle radius divided by, minus OM. So that means what I need is this PQ, that is B. This B is equal to PQ plus QM, or we can say PQ is the addendum plus OQ minus OM. Okay, OQ minus OM. Now, what is addendum? We know that it is 4. Now, what is OQ? OQ is equal to 64 because pitch circle radius. Now, what is OM? I think OM we have already calculated here. Yeah, OM we have calculated here. It is R, that is R cos theta, because this was theta and this is the base of it. This is radius. Till here it was radius. This is the vertical distance, perpendicular distance. So this is OM here. OM is equal to OQ cos theta, or rather can say pitch circle radius cos theta. So 64 cos 2.812. So from here I get B is equal to 4.077 mm. That is equal to approximately equal to 4.1 mm is the answer. So this may look very simple, but it includes a very analytical geometry and very shrewd acumen from our end. So anyways, question number 62 is over. So the answer is 6.2 mm is, I think, A, 6.28, and 4.1 mm, that is exactly, if I say it is 4.077 mm, is the B. Question number 63. While cooling, a cubical casting of side 40 mm undergoes cubical side, right? Cubical casting of side 40 mm undergoes 3%, 4%, 5% of first volumetric shrinkage during liquid phase transition, and solid state. So the volume of metal compensated from the riser is. So basically riser compensate two shrinkages. First, transitional shrinkage and liquid shrinkage. Therefore, it will be responsible for 7% volumetric compression. So therefore, it will be the important point is riser is responsible for transition compensation shrinkage and liquid shrinkage. Now question number 64. Therefore, the 3 plus 4 is equal to 7. So answer is 7%. Now question number 64. In a single point cutting tool, the side rake angle and the orthogonal rake angle are equal. Okay, so psi is the principal cutting edge angle, and its range of psi lies between 0 to 90 degree. So chip flows in the orthogonal plane. The chip flows in an orthogonal plane. The value of the psi is closest to. So answer is the chip is flowing in an orthogonal plane. So the angle of principal cutting edge angle is, that is psi, is 90 degree. Is 90 degree. It's not closest, it is 90 degree. Okay. Now question number 65. You see, a researcher conducts a electrochemical machining ECM on a binary alloy. Density 6000 kg per meter cube of iron, atomic weight 56, valency 2. Then metal P, atomic weight 24, valency 4. Faraday's constants 96,500 coulombs per mole, and volumetric material removal rate of the daily alloy is 50 mm³ per second at a current of 2000 ampere. The percentage of metal P of the alloy is closest to. So we have to find the amount of P that is being added, and also percentage amount of this iron that is added. So let us take the amount of PBP itself, and amount of percentage of amount of iron is Fe. So we found these two whatever thing that they given I have mentioned here. So MRR is equal to atomic. We know that for ECM, electrochemical machining, MRR is equal to atomic weight into current, that is A into I, divided by rho into valency into Faraday's constant. Okay, here they have given two metals. So what we will do, we will take atomic weight in the denominator and we will just sum it up. We will summation of these two things. Okay, so here you will get the MRR they have given 15 10 power of minus 9, current they have given 2 kilo ampere or 2000 ampere, and density 6000 kg per meter cube of the entire thing. Yes, binary alloy of the it's a combination. It's 6000 kg per meter cube, and Faraday is constant 96,500. Now here comes the picture. Valency is 2, and atomic mass is 56. Now percentage of iron I have mentioned here 50 as Fe. Fe represents, remember, Fe represents percentage of iron. You can also write Fe by 100 to get the absolute value. Similarly, 4p by 24, you can also write 4p by 2400 in order to get the absolute value of the p. Now from here you will finally get an equation. If you solve it, you will finally get an equation. Okay, so if you solve something like this, now what you will do, you will simply put the look at the options. Okay, that means here I will be putting, rather than in place of p, I will be putting 0.25. If I put 0.25 in place of p, I get my answer as very nearest to it. Okay, because they have asked in terms of percentage, right? Percentage of p in the alloy. So in p, in place of p, if you put 0.25, since a binary alloy, for iron you will put 0.75. Similarly, if you check each and everything, each and every option, you will find that 25, the option 25 will give the most accurate answer. Okay, this is the only way through which you can solve this question. So answer will be, p will be 25%. Okay, and here you, whatever you will put, it will be 0.25 will be the answer. Here you will get put 0.25. Now question number 66. A single pass rolling operation 20 mm thick plate with the plate width of 100 mm is reduced to 18 mm. The roller radius is 250 mm and the rotational speed is 10 revolutions per minute. The average flow stress for the plate is 300 megapascal, average flow stress. Power required for the rolling operation is in the kilowatt is. So basically power required is by the rollers. Okay, so for that, the first thing that we need to calculate is the deformation zone. That means total length of that roller, which is picking, starting from the touching the sheet to the ending the sheet. So that is the arc that will be. So that length we need to calculate. So first here we will calculate the mu. Mu is equal to square root of delta h by r. That is equal to delta h. That means it is single pass. So from 20 mm thickness to 18 mm thickness. That means it is reducing 2 mm, and what is r? It is 250 mm roller radius. So square root of 2 by 250. So mu I got 0.039. Now what is the deformation zone? Deformation zone is equal to square root of r into delta h. So from here I get the length that the roller is catching up the catching and leaving the strip, metal strip. Okay, this is 22.38. Now we have to find h average, because we don't know the exact force across the from entry to exit. So we'll take the average length. So average height, rather we can say, that is 20 is the initial height and 18 is the exit height. So average height is 19. Now what is f average? This is the formula that you need to remember. F average is equal to 2 divided by square root of 3 sigma y, that is flow stress, b is the width, L is the length, whole into 1 plus mu into length divided by 4 into h average. I again repeat, the force average. So before finding the torque, we need to calculate the force, right? Force that is acting, because force into the radius of the roller will give the torque. Okay, and henceforth we can calculate the power 2 pi nt by 60. But first we calculate the force, average force that is acting on this roller when it is picking the strip and it is drawing, or rather compressing it. So till the entry to the exit point. So F average is equal to 2 divided by square root of 3 flow stress, that is sigma y into width into length whole into 1 plus mu into length of the strip or length of the deformation zone divided by 4 into average height. Okay, so if you put those equations, put those values, you will get F average is equal to 794, rather it's we can say 794.855 kilonewton, we can say. Now what is arm length? See, arm length is actually, we can say, the radius of the roller. Okay, not exactly the radius, but we call that the arm length, which is responsible for the complete means it acts as, it is just acts like a radius which is used to calculate the torque. Okay, this, the value for this is lambda N12, that is 0.5 into the deformation deformation length, that is 0.4 into length. So 0.4 into 22.36, that is equal to 8.944 mm. Now from here you get the value of torque, that is F average into the arm length. Now from here you get the corresponding value of torque in Newton mm, and now from the torque you can calculate the power. So power is equal to 2 pi nt by 60. So from here you get the torque, that is, this is the power that is required per roll. Okay, so you will, now what you will do, you will simply multiply it by 2 in order to get the total power required in the 2 rolls. Okay, the power required for rolling operation in kilowatt is closest to, it is 14.8 kilowatt is given. So answer is nearly equal to 15.2 kilowatt. Okay, so two things you remember: arm length we put, it is just like a radius that is required to calculate the torque, and second thing is this F average. These two things we need to learn about. Okay, let us see question number 67. In the arc welding of a butt joint, the welding speed is to be selected such that highest cooling rate is achieved. Melting efficiency and heat transfer efficiency is 0.5 and 0.7. Okay, whenever this type of efficiency comes into picture, we generally see so this type of efficiency is actually attached to the electrical energy that has been given to the workpiece. Okay, so just simply multiply these efficiency with the electrical energy. The area of the weld cross section is 5 mm square, and the unit energy required to melt the metal is 10 joule per meter cube. Okay, so it is, they have given joule per meter, means joule per volume into this area, you will get joule per second. Okay, and if I multiply with some velocity, I will get the answer. So basically the welding power, the electrical power is 2 kilowatts. So what I will do is 2000 multiply by all the efficiencies that they have mentioned is equal to, this is heat density 10,000 joule per mm cube, then 5 mm square, I think mm square area, and this is mm per second. If you solve it, you will get the velocity as 14 mm per second. So answer is 14 mm per second. It's a simple question. Now question number 68. In a deep drawing of cups, blanks show a tendency to wrinkle up around the periphery flange. The most likely cause and remedy for the phenomena are. You see in the question paper 2007, I have explicitly shown you what is the wrinkle. I have shown you in the diagram. Please go through and check. The same question has been repeated this year in a different way. The cause. Now what is the cause there? The cause, I told you that it was because of insufficient holding. Okay, because of insufficient holding. So what will happen in the insufficient holding? It will be buckling due to circumferential compression. Okay, now what is the remedy for it? Increase the blank holding pressure. Option A is the answer. Now question number 69. In the figure shown, it's a very beautiful question. Okay, so in the figure shown below, an incomplete schematic diagram of a conventional lathe is to be used for cutting thread operation with different pitches. The speed gearbox, that means here if you apply at P, apply at Q, it will give different pitch and all those things. Okay, the speed gearbox UV, the speed gearbox, actually there are two gearbox. This should be UV. Okay, it is UV. UV is shown, and the feed gearbox US is shown. US, okay. Feed gearbox uh, US is to be placed. Sorry, US is to be placed. I need to place a. There are two feed gearbox. I will tell you what all those things to be placed. PQRS are the denote the locations and have no other significance. Changes in U changes in UV changes in UV should not affect the pitch of the thread being cut, and changes in the US should not affect the cutting speed. Okay, it's a very beautiful question. So first you see the mechanism of lathe. Here is the workpiece. The workpiece actually rotated in the headstock. Okay, here is the motor. Basically the motor gives a speed at a very high speed. So in order to reduce the speed on our user defined space, we use something called some gearboxes, give some gear arrangement, so that we can do some significant speed reduction. Okay, so here from the motor, what the this gearbox, this additional gearbox has been attached, speed gearbox has been attached in order to step down the rotational speed of motor to our user defined way. Okay, now we have to also apply a gearbox here, so that the power that we are getting from the motor should be applied to the lead screw, because here lead screw is also rotating, in over which the half nut is moving from this side to this side, of course, so that the screw can be cut, the screw threading can be done. Now you see here, this is very important. They have mentioned that UV should not affect, means UV should not affect the pitch of the thread being cut. Now what is pitch of the, how the pitch of the thread is cutting? You see, pitch is nothing but the length of the spiral that is taking place. Suppose this is my workpiece. The workpiece is actually rotating, and this particular thing, that is our thread cutting tool, is actually taking a feed or transfer, just simply transversing. Okay, so wherever it will transverse, it will only transfer, so it will make a helical groove. This is nothing but the screw thread that we are making, right? So from this point to this point is called pitch. As we all, it's the basic thing that we must know, rather. This is the pitch. Okay, now there are two things. Pitch is equal to length of the spiral divided by number of spiral. Okay, I again repeat this. The pitch is equal to length of the spiral divided by number of spirals. Okay, so this, where this length of the spiral depends upon, the length of the spirals, the spiral that has been created, will depend upon the RPM of the workpiece. Okay, the rate at which the workpiece is being rotated will define the length of the spiral. If it is rotating very fast, so this length of the spiral will be very small. If it is rotating very slow, the length of the spiral will be, this spiral will be very long. Now divide by number of spiral. If suppose this spiral is this much, this is the length of the spiral, and this is the number 1, 2, 3. There are 3 turns. Spiral means turns, I am saying. So number of spiral depend upon the feed rate of the lead screw. This half nut is moving right in this direction, so feed rate of the lead screw will depend, means number of spiral will be depend upon the feed rate of the screw. That means if our half nut is, the lead screw is rotating very fast, then very small spiral, means very small distance will be created. Very small spacing will be created in the screw cutting. So the pitch is equal to length of spiral divided by number of spirals. Okay, if it is moving very fast, that means lot of spiral will be created within very small short of time. That means my pitch will be very small. If it is moving very slow, so number of spiral will be very large again. Now that means, now if you observe it carefully, what they have asked is, where should be the placement of US? Where should be the placement of US? Where should I keep US, so that so the first option, if you see, between Q and E. Okay, between Q and E, placed is given by Q and E, and placed between P and Q. And second option is S and E. Okay, so you observe it carefully. That means since they have already told that the pitch has to remain same, here they have mentioned not affect the pitch. Since they have told that it should not affect the pitch, that actually mean the speed of the speed with which workpiece is rotating, with respect to that we will be fractioning the speed with which the lead screw is rotating. That means any change in the workpiece should be making the change in the lead screw accordingly. Okay, so that these two factor rpm of workpiece and feed rate of the lead screw should be proportionally changing, so that it not affect the pitch at the end. Okay, therefore where should we keep it? We should be keeping it, so we should be keeping it between S and E. I hope it is clear to you. Now look at the options. We cannot connect this between P and Q and R and S. Why? Because if suppose you if you put that drive box here, if you put that drive box here, the entire energy of the motor is going from this side to this side. That means our workpiece may not get energy properly. Okay, that means entire energy of the motor will be connected to this point. If you keep it within R and S, then between option A is not possible, because the entire energy will be gone through the lead screw of the motor. Now it will be given, now the QS is given by S and E connected between R and S. This is also not possible. Okay, because ultimately the workpiece will be rotating in different speed and your lead screw will be moving in different speed. Now QE is connected, QE are connected, Q and E are connected, US is placed between Q and E. If this happens, then the lead screw, as I told you, the lead screw will rotate in a different way and the cutting tool will rotate in a different speed, so the pitch will be disturbed. Okay, therefore only one thing exists, that is it should lie between S and E. We should attach it between S and E, because the motor gives the energy to UV. Okay, now based on that we can drive the we can manipulate. That means if we change something related to UV, automatically our US is also getting connected, our US is also getting changed. Okay, if US is getting changed proportional with respect to UV, then there we will not disturb the pitch. So answer will be QS should be placed between S and E, and US should be placed between S and E. So S and E should be connected and US should be placed between S and E. So that proportionality we can change the workpiece speed also, as well as our lead screw also. Okay, so this was the concept. So if you don't understand this, do let me know. I can reiterate once again for you. Question number 70, you see, a displacement sensor dial indicator measures the lateral displacement of a mandrel mounted on a taper hole inside the drill spindle. Mandrel axis of the extension of the drill spindle, taper hole axis and protruding portion of the mandrel surface is perfectly cylindrical. Okay, the measurements are taken with the sensor placed at two positions P and Q. The readings are recorded as Rx. Rx is the maximum deflection minus minimum deflection, correspond to the sensor at the position X, at any position X, over one rotation. So if RQ is equal to RP, that means RP is equal to RP, if I say maximum deflection minus minimum deflection at say particular point P, at particular point P here, suppose this is a point P and this is a point Q. So RP is equal to RQ. That means the surface roughness, okay, lateral displacements. Okay, so the lateral displacements, the mandrel mounted on the tamper shaft, maximum deflection. So basically maximum deflection at point P and point Q are equal, okay, and greater than 0. Which of the following would be consistent with the observation? Okay, so maximum deflection, here the maximum deflection is greater than 0, here the maximum deflection is greater than 0. and it is equal. That means that our sensor, rather our cylinder, is actually aligned with the axis. Okay, therefore the drill spindle rotation axis is coincident with the drill spindle taper hole. Okay, otherwise these two would not have been same. This is the concept behind it. Now question 71. In the figure shown, the system is a pure substance kept in a piston cylinder arrangement. The system is initially two-phase mixture containing 1 kg liquid of 1 kg of liquid and 0.03 kg of vapor. First, we can find the X. Okay, that is 0.03. The pressure at 100 kilopascal. Initially, piston rests at the set stop shown in the figure. The pressure of 200 kilopascal is required exactly to balance the weight of the piston and outside atmospheric pressure. Okay, that means the pressure is actually there is outside, there is atmospheric pressure. Now the heat transfer takes place into the system until its volume increases by 50%. That is V2 is equal to 1.5 V1. Now heat transfer to the system occurs in such a manner that the piston, when allowed to move, does so in a very slowly, that is quasi-static, quasi-equilibrium process. The thermal reservoir from which the heat is transferred to the system has a temperature of 400 degrees centigrade. Average temperature of the system boundary can be taken as 175 degrees centigrade. The heat transfer to the system given to the system is 1 kilojoule. So during which its entropy increases by 10 joule per Kelvin. Okay, they have given some values of the saturation pressure, saturation temperature along with the VF, VG. So at the end of the process, which of the following situation will true? First, superheated vapor will be left in the system. That means the quality of the steam will be 100%. No vapor will be left in the system. Liquid plus vapor mixture may be. So basically, they are asking with respect to the mixture. Okay, so initially they have given that there is if you observe it, what is the X value? As I told you, it is X value is 0.3 vapor divided by 0.3 divided by 1.03. So X is equal to 0.0291. Okay, is the quality of the mixture right now. Where it is right, so at outside it is atmospheric pressure is 100 kilopascal. Now what is the specific volume that is acting at 100 kilopascal? At 100 kilopascal, so what is specific volume? So what is V1 right now? V1 is equal to at 100 kilopascal, right? At 100 kilopascal, let me read once again. The pressure at 200 is required exactly balance the weight and okay. The two-phase mixture containing 1 kilogram of liquid and 0.3 kilogram vapor at a pressure of 100 kilo. So basically it is right now at 100 kilopascal. This mixture at 100 kilopascal. Okay, I see 100 kilopascal, I get VF and VG. That means my volume, present volume of the system will be V1 is equal to Vf plus X into Vg minus Vf. You simply minus it and you will get V1. That means my present volume is 0.00388 meter cube per kg. Okay. Now, what they have told, I again read this. A pressure of 200 kilopascal is required exactly balance the weight of the piston and outside atmospheric pressure. Okay, the heat transfer takes place into the system until volume become 1.5. Okay, so volume now changes to how much? P1, that is exactly 200 required, right? So it is now 100 kilopascal. Initially it was 100 kilopascal. Now the pressure 200 is required exactly to balance the weight outside. That means now the pressure has been changed to 200 kilopascal and the volume has been changed to 1.5 V. So pressure from 100 kilo to 200 kilopascal, V2 has been changed to 1.5 V1. That is equal to, if I take V2 is equal to 1.5 of this much amount, that is equal to 0.0057 meter cube per kg. Now you see here, if you observe it at 200 kilopascal, what is the saturated volume, that is saturated vapor volume, that is equal to 0.002 meter cube per kg is the saturated vapor volume at 200 degrees centigrade. Okay, now what is the vapor volume we have? That is equal to 0.0057. What that actually mean? It means that our state right now is superheated state. That means it is beyond means the it has exceeded the x is equal to 1, means dryness fraction is beyond 100%. So right now our state of the steam is superheated state. Okay, this is what they have asked. So it will be mixture superheated vapor will be left in the system. Now work done by the system during this process, simple. Work done by the system will be, initially it was, so if I make a graph of it, initially it was 100 kilopascal. Okay, initially it was 100 kilopascal. Now then it moved to 100 kilopascal and some V1. Now it moved to 200 kilopascal and it is quasi-static, right? In a quasi-static way. Okay, it is in quasi-static way. So it will be in this way. Initially it was this one, now it moved to this point. That means from P1 is equal to 100 kilopascal, V1 is equal to 0.0038, 0.0038, and here now it moved to P1 is equal to 200 kilopascal, V2 is equal to 0.0057, 0.0057, 0.0057. Okay, now what is the work that has been done? That is what we need to calculate. Okay, now the most important, it is not simply we calculate, it is will be in terms of per kg. But the what is the mass of water vapor mixture? It is 1.03. We have calculated, right? Total mass is 1.03. So we will simply multiply 1.03 here and we will get 0.195 as our answer. So answer will be 0.195. This is nearly equal to 0.2 kilojoule total work. Now the net entropy generation considering the system and the thermal reservoir together during the process is closest to. Okay, what we have to, the entropy generation. Okay, now entropy generation, that is what is Q in, that is they have mentioned, right? We have the heat transfer to the system is 1000. That means 1000 is given to the system at what? Average temperature is 175. So 175, if I convert it in terms of degree, means Kelvin is equal to 273 plus 273 plus 175. 273 plus, actually wait. The thermal reservoir from which the heat is transferred to the system is at 400 degree average temperature. I am sorry, since the heat is released from the thermal reservoir at 400 degrees centigrade and the heat released is 1 kilojoule, so it will be minus 1000 divided by 400 plus 273. So from the surrounding you are getting this much amount of heat is getting extracted from the source. Now the average temperature of the system boundary can be taken as 175. Okay, so delta, so due to which the entropy changes this. So what they have asked, actually they have asked the net entropy generation. We know that entropy generation is equal to delta S of system plus delta of surrounding. So delta of system, they have already mentioned that it has gained an entropy, increases by 10 joule per Kelvin, and we found that the surrounding is equal to, surrounding has given the system, given the heat to the system, that is minus 1.485. Therefore delta at generation is equal to delta S of surrounding plus delta S of this system, that is 10 minus 1.485, that is equal to 8.511 joule per kg. This is the answer. Now have they given anything? The entropy generation is, okay, one thing I did not mention here, it should be 1.511 joule per kg, but we have to also multiply, wait, joule per kg, yeah, it's correct, it is correct. We have we will not multiply mass here because there is no concept of mass. It is actually Kelvin. I have wrongly mentioned kg. It is joule per Kelvin. So answer will be 8.511 joule per Kelvin. So answer will be 8.5 joule per Kelvin. This is the answer. Now question number 74, 75. Actually before going to the question number 74, 75, I need to give you the recap of simplex method. Okay, I think I have previously told you that I will be giving you the recap of simplex method. Suppose this is the objective function with the constraint they have mentioned. Okay, so what is slack? Slack is a unutilized capacity. Okay, so I will in a normalized form, how we will write it? We'll write z is equal to 3x1 plus 4x2 plus 0s1 plus 0s2. In constraint form, I will write, remember, in simplex form, if the objective function is maximum, then the constraint will be in less than equal to symbol, except these are decision variable that has to be greater than 0. So but the constraint, the main constraint, should be in less than equal to. If the objective function is in minimization, then the constraint should be in the greater than equal to symbol. Now we will write in the form z is equal to 3x1 plus 4x2 plus 0s1 plus 0s2. Now the constraint will be x1 plus x2 plus s1 plus 0s2 is equal to 450, x1 plus s2 plus 0s1 plus s2 is equal to 600. Now we need to find initial solution, basic solution, and feasible solution. So at x is equal to 0, x2 is equal to z is equal to 0. So these are non-basic decision variables. Okay, and s2 is equal to 450 and s2 is equal to 600. When x is equal to 0, x2 is equal to 0, z is equal to 0. So we get as z becomes 0. So these are non-basic decision variables. At that point of time, s1 is equal to 450 and s2 is equal to 600. These are basic slack variables. Okay. Now we will first make the simplex table, or the initial basic feasible solution table. So here we will make columns like CB, basic column, rather basis column. Here this will be the basis that we are entering. This will be the CZ column, that is coefficient of the objective function. So objective function, our objective function is 3400, and here will be the, so these are actually constants. Okay, this will never change across the operation. Here is the RHS with that we will put. So here this constant x1, x2, s1, s2. CB is the coefficient of s1, s2, that is basis variables. It is 0 and 0. Okay, now what is basis column? It represents the basic variable, that is variable at that stage, at that particular state. What the basic variable? CB is the coefficient of the basic variable. Okay, now we will move on to solving this question. So we will write the constraints: x1 plus x2 plus 1 s1 plus 0 s2 is equal to 450, 2 x1 plus x2 plus 0 s1 plus s2 is equal to 600. Now you put here. So if you put here, now we will find two things. First, zj. Okay, zj is equal to how much? Zj is equal to summation of cb, this cb into the corresponding cz vector. Okay, it is not x, rather it is corresponding cz variables, that is x, the corresponding values of cz. Okay, so that means, for suppose for this point, 0 into 1 plus 0 into 2, that is equal to 0 plus 0, it is 0. 0 into 1 plus 0 into 1, that is 0 plus 0 is equal to 0. This is summation of all CB into those variables, slack variables and basic variables. This is for this 0 into 1 and 0 into 0, 0. 0 into 0, 0 into 1, it is 0. Again 0 into RHS 0, and so on. Now again, net evaluation row is equal to CZ minus ZJ. So CZ minus ZJ means CZ is this one, 3 minus 0, 4 minus 0, 0 minus 0, 0 minus 0. That's it. Okay, now we will see the highest column in the CZ minus Z, which is the highest value. So this 4 is the highest value for me. 4 is the highest value. So this column we will take. This is our key column. Okay, and this value 4 is our entering variable. That means, I'm sorry, this zx2 is the entering variable. That means in the next iteration, x2 will be entering. Where it will entering? First, so for that we will find the ratio of it. That is 450 divided by this key column. Okay, 1. Then 600 divided by 1, which is the least ratio. This is the least ratio. That means this is our key element. 1 is our key element, and s1 will be the leaving variable, and x2 will be the entering variable. Remember this, I am mentioning here. S1 is the leaving variable and x2 is the entering variable. Now this is the key element. That means we will do all the operations to make this particular row element, this particular element as 1, and we will apply for the across row. Okay, and we will try to make this particular element as 0. The other guy we will try to make it 0. So how we will make it? So before that, let's see the theory. X1 is equal to 0, x2 is equal to 0 if they are not on a basis column. Okay, if they are not on the, so here in the basis column, x1 is equal to 0, x2 is equal to 0 if they are not in the basis column. If the problem is of maximum z, that is, so if the problem, remember, if the problem is maximum z is negative or 0, that means when our net evaluation row, when the problem is of maximum z, uh, when the problem is of maximum z, cz should be, we should bring cz should be negative or 0. If not, then then uh, so we have to check whether all these values are coming negative or 0, just to then only we can get the solution to be optimum. Okay, then if it is taking the, suppose it is a problem of minimum, then we will take the negative cz minus zj. Okay, but for the time being, since this is a maximized problem, we will operate in such a way, we manipulate the tables in such a way that we get cz minus zj in a negative or in a 0 form. Okay, now the basic problem that we will do is, the basic thing that we will do is, we will take the key column, keep it as 1 only. Other elements of this key column will be turned into 0. How we will turn? So what we will do is, in the next table, what we will do, we will try to convert this in 1. How we will convert? We will simply divide it, each and every element in the row by 1. If I do it, I will be getting 1, the same 1, 1, 0, 450. Now I will convert this into 0. How will convert this into 0? I can convert this into 0 by 1 minus of 1 into this key element. So I can write, right? If I want to manipulate this one, how I can write? 1 minus 1 into key element. Okay, so that this will give. So I will do it same everywhere. That means 2 minus 1 into 1. It will become 1. 1 minus 1 into 1, 0, 0 minus 1 into 1, minus 1, 1 into 1 minus 1, 1 into 1, that is equal to 0, 600 minus 450 into 1, that is equal to 150. The same thing we will do here. So if I see here, you will find 1, I will convert this element as 1, s2 becomes our entering element, then x1 becomes our entering element, I think x1, right? No, sorry, x2 should be our entering element. X2, here it should be x2, not x1. X2 is our entering element, and S1 is our leaving element, and I converted entire thing is 1, 0, minus 1, 0, 150. Okay, now what we will do, we find the cz minus zj. I found that the again I will calculate the corresponding zj. Zj will be 4 into 4 plus 0 into 1, that is equal to 4. Is equal to 4. Then 4 into 1, 0 into 0, that is equal to 4. 4 into 1, 0 into minus 1, again it is 4. 4 into 0, 0 into 0, it is 0. Okay, 4 into 450, that is equal to 1800. 0 into 150, the sum is 1800. Okay, now cz minus zj. Cz minus zj is this 3 minus 3 minus zj is minus 1. 4 minus z4 is 0. 0 minus 4 is minus 4. 0 minus 0 is 0. So here what net evaluation row, whatever we got, is a negative or 0. That means we have already, so we got the solution. That means what is the maximum value? Our maximum value of z will be 1800. What will be the x1 value? Sorry, x2 value. X2 value, actually x2 value should be 450. This is since x2 is a entering variable. Yeah, since x2 is the entering variable. Since x2 is our entering variable, so x2 will be variable will be x2 will be 450 in the RHS, you can see. And let me change it. X2 will be 450, x1 will be 0. So this is the solution of our problem. Okay. So they have mentioned S2 is equal to 150. What that actually mean? That means S2 is equal to 150 means machine 2 is unutilized for 150 hours, because S1 S2 represents the unutilization rate. Therefore machine 2 is being unutilized for 150 hours. Okay. And what about machine 1? Machine 1 is being used more than machine 2. This is the basic theme. So I hope you understood this. For the first, what we do is we first make the column basis vector, basis coefficient column, basis, what are the basis variables here we will write, CZ variables we will write here. Then we will calculate the corresponding ZJ, that is equal to the product of the summation of CB into those corresponding excess values and all. Then we calculate the net evaluation row, CZ minus ZJ. And since it's a maximization problem, we will make sure that the summation should be summation should be negative or 0 in order to get the final result. If it is not coming negative or 0, we will solve and solve and solve. Okay, till that point, until unless we get it. Okay, now after that we'll find the highest key column. By the highest key, this one, and that particular variable, basis variable, will be our entering variable, and this one on the basis vector, it will be the leaving variable. Now we will find the ratio across the row. Once we find the ratio, we will take the least ratio and we will cross it, and we will find the key element. So whatever key element we will find, we will keep that key element as 1. Okay. So here in the next operation, what we'll do, we'll try to convert this key element into 1, and rest other elements, so the same and applying the same operation across the row. And the below operations, we will try to keep this particular element as 0 and applying the same logic or same manipulation across the row. So from here we will get this value, and again we will calculate the corresponding ZJ and ZZ minus ZJ. And once we find all those net evaluation row values to be negative or 0, we assume that we got our solution. That will be our final solution. Now coming to our question. Now the question states that after some simplex iteration, the following table was obtained. Okay, so the basic variables they have mentioned, S is equal to 6, T is equal to 6. Okay, S is equal to 6, T is equal to 6. S is equal to 6, T is equal to 6. The objective okay, after some complex iteration, the following table was obtained. That is, S is equal to 2, Y is equal to 2. Okay, so which of the following will conclude? So if you observe it, if you observe the top column, that is at the end, it is all the basic variables are 0 except this 2. Okay, so 0 has appeared in the non-basic variable x and y. So optimal solution is not unique. So answer will be optimal solution is not unique. I will give you detail about whether the optimal solution is unique or not unique in some later solutions. But for the time being, just remember that if the optimal solutions, if the non-basic variables are 0 in the after solving so many problems in the table, then we are not getting a unique optimal solution. We will get a degenerate solution rather. Okay. Now question number 75, I think this is related to it. It's very simple actually. They have given question number 74. Okay, the dual for the LP in the question is minimum of this. Dual of the LP. This is the problem, right? Dual will be. Now how to calculate dual? You see, okay, first my maximum will become minimum, and all these constraints will become our objective function. Okay, how it will become? You see, from constraint we calculate the objective function. Now how we'll calculate the objective function? You see, minimum of, you see, first we convert maximum to minimum of RHS 6x, rather 6u plus 6v, this much, subjected to 2x plus 3y is less than equal to, rather it's minimum, right, greater than equal to 2x plus 2u plus 3y 3v is greater than equal to 4. Something like this you will get. 3u rather, they have mentioned 2u plus 3 greater than 4. Let me write it. This is the first constant, right? So 3u plus 2v will be greater than equal to 4, and 2u plus 3v will be greater than equal to 6. So 3u plus 2v should be greater than equal to 4, and 2u plus 3v will be greater than equal to 6, where u and v will be definitely greater than 0. So 3u plus minimum of 6u plus 6v, correct? Minimum of 6u, minimum maximum of will become minimum. So 6. So this option A will be the correct answer. Okay, no need to look over other things because minimum 6u plus 6v is not there. So question number 76. So they have given a cylindrical container of radius 1 meter as radius, and wall thickness is 1 mm, is filled with water up to a depth of 2 meter. So this depth is 2 meter and suspended over a upper rim. Okay, this suspended over the upper rim. Density of water 1000 kg per meter cube. Acceleration of gravity is 10 meter per second square. Self weight of the cylinder is negligible. Formula of the hoop stress in the thin cylinder wall can be used at all the points along the height of cylindrical container. So first question that they have asked is the axial and the circumferential stress that is experienced by the cylindrical wall at midpoint, that is 1 meter as shown. So first we find the circumferential stress. Circumferential stress we know that is otherwise known as hoop stress. It is equal to PD by 2T. Okay. So what is P? P is pressure, I think. Pressure at 1 meter is equal to rho GH. Density into gravity 10, 1 meter. It's the it's a pressure. Now circumferential or hoop stress is PD by dt. Just put the formula. P, diameter is radius, they have given 1. So diameter will be 2. Then 2 divided by 2, and T is the thickness, that is 1 mm. So we will take 1 divide by 1000. So this 1000 10 power 3 will go up. So it will be 10 megapascal. Now coming to the axial stress, which is very important here. You see, when you say axial stress at this particular point, okay, so the axial stress is actually acting at this direction in along the axis. Okay, and when it is acting along the axis, it is actually acting here along this thin shell. The axial stress experienced by the thin shell, that means we have to calculate first the force that is acting because of this water. That means rho gh. This is our rho gh into what is the area? It is pi by 4 d square, or we can say pi r square, because this is the area, right? This is our area where it is exerting force. So this is the force that is acting, and this is the force that is acting, and this is the area. So pressure into force is equal to how much? It is force that is acting, this force exerted by this water. Now where it is acting? It is acting on a stress on a thin shell, right? If it is on a thin shell, means this force that is acting, the force that is present here by 1 meter is actually exerting its force here at this thin shell. So for thin shell, what is the area? For thin shell, the area is 2 pi t into r. For thin shell, area for thin shell is equal to 2 pi r into t. I hope you remember this type of formula we generally come across, 2 pi r into t. So this 2 pi r is the radius, t is the thickness. So 1 divided by, since it is mm, so 1 divided by 1000. So here we got sigma A is equal to 10 megapascal. Therefore axial stress and circumferential stress is equal to 10 megapascal. So I hope you understood how this question will be solved, especially the axial stress. Axial stress will be, first we calculate the force because of water, then we divide it with respect to the area of the thin shell. Okay, now question number 77. Now it's very easy. The Young's modulus and Poisson's ratio has been given of the container is 100 GPa and 0.3. We have to calculate the axial strain, that is epsilon L. Epsilon L is equal to axial stress by E minus mu into radial stress or hoop stress by E. That's it. Just put the formula and you will get the corresponding answer as epsilon axial, because the forces stresses are acting in both direction, axial as well as radial direction. In order to find the axial stress, We need to find the axial strain minus the mu into the circumferential strain. That's what we did. Now question number 78. Here it's the same thing that we have did in all these years. They have asked the question regarding the eccentric, means we have to calculate the primary shear stress. Okay, primary shear stress and secondary shear stress. Now you see here, I'm again solving it. So there is an external force that is acting of 4 kilonewton. Okay, so because of this 4 kilonewton, there will the primary shear loads will be means this P and Q will be equally loaded, means equally distribute this 4 Newton. Okay, that means this I have marked with blue color, FP or FS. FS, it's actually primary shear. So primary shear means I mentioned it in S. So FPS is equal to FPS of P and FPS of Q is equal to 2 because this will equally distributed. Now this force 4 kilonewton will be how it will affect the this joint. At the center it will try to create a moment about this. So due to which they will these two supports will try to create an equal and opposite force. That is why it will bend in this direction and it will bend in this direction. That means here you can see in the red color, you will find this the secondary shear force will be acting in this direction, and here the secondary shear stress will acting in this direction. Okay, that means the equal and opposite couple will be a moment will be created in order to balance this moment. Now question is how we will calculate the secondary shear stress. Now the total moment that will be generated because of this 4 kilonewton will be 1.7 meter plus at the center point. What is the center point? 100 plus 200, because at 200 here this will be a center point to this. So 1.7 plus 0.3, that is equal to 2. That means 4000 into 2, that is equal to 4000, that is 4000 Newton meter of moment will be created, and this moment will be balanced by this point P and Q simultaneously. Now I'm not talking right now about primary force. Let us solve the shear force, secondary shear force. We know that secondary shear force is directly proportional to R. I think I have already explained in the previous year questions when I was solving, but still I am explaining it once again. So primary shear force, so secondary shear force is directly proportional to R. That means secondary shear force is equal to some constant of proportionality into R. That means total moment is equal to summation of all secondary moments. That is equal to secondary moment, rather secondary force into R, that is CR square into CR square is equal to 8000. From here I get the value of C. Our C value is 8000 divided by 2R square. So C is equal to 4000 divided by this 0.2 square. 0.2 square we got because this radius is constant, right? This radius with respect to this center is constant, that is 0.2 square. From here I get the value of C is equal to 1 lakh. C is equal to 1 lakh. Now just put it in SP and SQ. It will be we know that it's C into R. So C into R, that is equal to 20 kilonewton is the secondary shear force that is acting at P and Q. Now we know that primary force that is acting at each point is 2, and secondary shear force that is acting is 20 kilonewton. I think that is what only they have asked in load P, right? In bolt P. Now if you observe the bolt P, in order to counterbalance this moment in this direction, this moment will act downward. This red represents the direction of the secondary shear force, and this blue represents the direction of the primary shear force. But anyways, they have not mentioned the direction. They are concerned primary and second shear force. It will be 2 and 20. Okay, now the resultant shear force acting on the P is closest to. Now shear stress, right? So the net shear stress that is acting is opposite direction, that is 20 minus 2, that is equal to 18, and 18 divided by this corresponding diameter they have mentioned. I think they have mentioned, right? Steel bar of 10 cantilever M12 bolts. So the diameter is 12. Okay, pi into d square by 4. So the net force that is acting is 18 kilonewton, 18 10 power of 3 divided by pi by 4 d square. If you put, you will get the shear stress value is 159.1 megapascal. So answer will be 159.1 megapascal as my answer. Now question number 80 and 81. A gap between, I think we have already solved this question previously, but anyways, let's see. A gap between a moving circular plate and a stationary surface is being continuously reduced as a circular plate comes down at a uniform speed v toward the stationary bottom surface as shown in the figure. In the process, the fluid contained between the two plates flows out radially. That means the fluid is flowing out radially. The fluid is assumed to be incompressible and inviscid. The radial component VR at any radius R with a gap width h is. Okay, that means we know that V in, that is volume in, is equal to volume out, that is equal to pi r square into the velocity with which it is going in. Pi r square, this is, let us consider this as a radius. Yes, here I have considered this as a radius. Pi r square into this volume with which we are going through, divided by is equal to 2 pi r, 2 into pi into r into this height h, at this moment height h is equal to v radial. This red color represents v radial. Okay, this velocity, this very small thin surface I take. Okay, 2 pi r into h, this h is equal to v radial. From here we got the v radial, I take it, say vr. So v radial is equal to vr, say vr by 2h. So answer will be vr, the radial velocity is equal to v into small r by 2h. Okay, now the radial component of the fluid acceleration at r is equal to capital R is. So first, for that we need to understand what we need to mug up the formula for acceleration, radial acceleration. Radial acceleration with respect to r, that is radial acceleration will be del v r by dt plus vr into del v r by dr. Just you need to remember this, and we have already find the value of vr. Just put it here. Once you put the value, you will get the value, corresponding value of ar. Okay, so we don't need to worry about it because we have vr, we have already calculated it, and once we have calculated the vr, we simply put it here. So is there anything to discuss? So let me check. Here h is also decreasing, so h is also acting as a variable here. Okay, and vr, I think I have mentioned here vr by 2h, right? So yes, vr will be substituted with vr by 2h. Again, vr will be substituted with vr by 2h. Okay, so the numerator, both means differentiation of the numerator and differentiation will be taking place here. Okay, v will be, since v they have mentioned constant, I think uniform speed v, so v will be taken out and we will differentiate it. Okay, and see they have mentioned with respect to t, so we will differentiate with respect to t both r as well as h. Okay, now here they have mentioned del with respect to r, so we need not to worry about everything, just we differentiate with respect to r here. Okay, so vr is given. Okay, that's fine. So here the critical operation comes here, where we will be differentiating with respect to t. So dr by dt, what is del r by del t? It is nothing but vr. Okay, so we put the value of vr here, and what is del h by del t? They have mentioned v, that is uniform velocity with which it is descending, it is v, that's it. And here you put vr by 2h into v by 2h. Just put the value, and we'll finally get the corresponding value of acceleration, that is radial acceleration is equal to minus 3 by 4 v square r by h. Now question number 82, I think this is finished. Question number 82, 83. The orthogonal turning is performed on a cylindrical workpiece with a shear strength of 250 megapascal. Shear strength, okay. Now the cutting velocity is 180 meter per minute. Feed is given this much. Depth of cut is given, and chip thickness is given. Chip thickness ratio is given 0.5. Orthogonal rake angle is, now applying Merchant's theory, shear plane angle. I think for shear plane angle, tan phi is equal to r cos alpha divided by 1 minus r sin alpha. R is given, I think 0.5. Alpha value they have given. Rake angle, orthogonal rake angle is 7 degree. Just put the value and you can get. It's a it's the preliminary formula that we must know. Now, what is cutting force and frictional forces? Okay, for that I would say, so they have already mentioned, right? Merchant theory analysis. We have to use merchant theory analysis. For that, 2 into shear angle plus friction angle minus rake angle is equal to 90 degree. From here we get the beta value. Okay, now they have asked the cutting and the frictional forces. Okay, so we got the beta angle. Okay, now wait, let me check cutting and shear. I don't think I have calculated this cutting and the frictional. No, for cutting and frictional forces, I think we don't need to calculate all these things. I think I've calculated for the knowledge purpose rather. Okay. Okay, this was just for the knowledge purpose. Let me go back and calculate the shear force and frictional force, and then I will come back and explain you what extra I have calculated for you. Okay, so for cutting and the frictional forces, you don't need to worry about you. So you should know what is the merchant, how to draw the merchant circle, and we have already calculated based on the merchant's theory. We have already calculated the beta value. That means this is the beta value that we calculated. This is the beta value that we have calculated. Okay, now the question here is, we don't know the value of r. If we know the value of r, if we would have known the value of r, then we would have easily calculated the means at f friction by f normal is equal to tan of beta, but we don't know the value of r. So how we will know the value of r? You see here they have mentioned, I think cutting force, some force they have mentioned. Cutting velocity, shear strength they have given. Okay, in the previous question I need to calculate the shear force. Actually, I have not calculated. Okay, I will go back again and reiterate this problem, reiterate the first part. But anyways, I am coming to the second part. So let us see cutting force and the frictional forces. Cutting force and frictional force, let me calculate. So now what I will do is fs, this is fs, right? Okay. There is another shortcut way to calculate. How you will calculate? I know this beta, right? So this beta is equal to frictional force by the normal force is equal to tan beta. Okay, so what I will do is I will calculate the tan beta and I find the corresponding ratio. Whichever comes closer to this value, I will take that option. But anyways, for this I need some shear forces. I think shear forces I have already calculated prior to it. Let us assume that I take this value as 320. Suppose I will tell you how I calculated it. Just wait. So this is the one of the shortcut method that you just divide it, and looking at the options you put here and you calculate the tan value and you can get it. But let me go from the traditional way. You see, shear force I have calculated, that is I think 320 megapascal, 320 Newton or 319.5 Newton. That means this I have already got. I know the value of beta minus r. Okay, this phi value I know that. Okay, now I know the beta value and alpha value. That means I know this value. Okay, so I will calculate the value of r. So fs by r is equal to cos phi plus beta minus alpha. That means I got the value of r is equal to 677.22. That means I got the value, that is f cutting. What need to calculate? The cutting force and frictional force. I'm sorry, cutting force I need to calculate. So that means fc by r is equal to cos beta minus alpha. From here I get the value of fc. And what about frictional force? This frictional force is equal to frictional force by r is equal to 90 minus beta. That is equal to frictional force by r is equal to 90 minus beta. So I think beta is equal to 58 I think. Beta value is equal to 41 means 59. It should be, it's sine 1. Yeah, correct. It's perpendicular direction and this is hypotenuse. Friction value by friction force by r is equal to sine 41, or we can say cos 49 also, cos 59 also. So or we can say r sine 41. So friction force we got 440. Okay, so one thing I missed in the previous question was I have not calculated the shear force. So let me calculate the shear force. I've calculated, I think, the beta value. Now you see, for orthogonal cutting, this is very very important. Let's look at the diagram here. This is the tool. This is our tool. Okay, it is going in this way. This is the cutting velocity. This is the shear plane. This, if you go in deep into it, you will get the shear area. Okay, this is where shear, the chip is taking out, ripped off. So this is the shear velocity and this is the shear plane. Now what is shear plane? This is ls into the width. Okay, and how ls can be defined, the length of shear can be defined, it can be defined h by sine phi. Okay, so area of the shear, we can define it as ls into width. So ls can be defined as h1 by sine phi into width. Now what about orthogonal cutting? This is very very important. For orthogonal cutting, you need to remember breadth into h1, breadth, this width into h1 is equal to depth of cut into feed. Okay, so what we can replace? We can replace breadth into h1 is equal to depth of cut into feed by sine phi. So from here, area, that is area of shear, is equal to depth of cut into feed divided by sine phi. So from here I got shear stress is equal to Fs by As, and I think the depth of cut and feed value has been already given. I already found this shear force. Shear stress value. Shear stress into As. So shear stress value they have given 250 megapascal. 250 megapascal into depth of cut, I think they have given 3. Depth of cut is 3. Then feed is equal to 0.2. Feed is equal to 0.2 per mm divided by sine phi. Phi value, I think I have already calculated. 27.85. Just put it here and you will get the corresponding shear force. And this shear force will be used here. So you don't need to mug up all the formulas that are given in the book. You can calculate easily once you calculate this resultant force. Okay, and these resultant angles, and you know you should know the orientation of this merchant circle and all. Okay, now let us see question number 84. Statement of the linked, last two questions. Okay, in the feed drive of point-to-point open loop CNC drive, a stepper motor rotating at 200 steps per revolution drives a table through a gearbox and lead screw nut mechanism. They have given the pitch is equal to 4 mm and number of start is 1, that is single start. The gear ratio is output rotational speed by input rotational speed is given by u is equal to 1 by 4. That is, it is reducing the speed by 1:4. The stepper motor driven by the voltage pulses from the pulse generator execute one step per pulse. Okay. The frequency of the pulse train for the pulse generator F is equal to 10,000 pulses per minute. What is the basic length unit? BLU, if the table movement correspond to the one pulse. That is, means what is BLU? That is table movement correspond to one pulse. That means in one pulse, how much table movement is taking place? You see here, it is given 200 steps per revolution. That means one revolution is nothing but one pitch, and one pitch is how much? It is taking one revolution of motor, and one pitch is equal to how much? They have, I think it is told, right? One pitch is equal to 4 mm. Okay, and this gear ratio is given n output by input is equal to 1 by 4. That is, it is reducing the speed by 1 by 4. Okay, so 200 pulses is able to rotate the motor by one revolution. Okay, now how much the gear will be reduced, the output will be reduced? It will be reduced 4 times less. That means the linear that means in those 200 pulses, my linear distances will be 1 by 4 into 4 into 1. That is 1 mm linear distance will take place. That means 200 pulses, if one linear displacement is taking place, in one pulses how much it will take place? It will be moving. This is what they have asked. In one pulse, how much it will be moving? It will be 0.005 mm. That is equal to 5 micron will be the BLU value. Okay, if they have not mentioned this gear ratio, I would have been straight away taking the pitch as 4 mm, and I will straight away calculate that 200 pulses is responsible for 4 mm distance. But they have given the speed gear reduction ratio, that is output rotational by input, is 1 by 4. That means 4 times it is reducing the speed of motor. Therefore, one motor if reduces by 4, the speed of the motor is getting reduced by 4 times less when it comes to the lead screw or the output. Okay, that is why the one pulse is executing 0.005 mm or 5 microns. Now what is the feed? Feed, how much feed? The means the speed at which it is moving. It is equal to BLU into pulses per minute. Per minute basis. That means 5 micron into 10,000 pulses per minute. That means 50 per minute basis it is traversing. Okay. Why I am calculating feed, you will get in the next question. The customer insists that the modification to change the BLU of CNC to 10 micron. So initially my feed was 5 micron. So now I will be changing the BLU to 5 micron. Okay. So what is this BLU? That means 10 pulses I will be invoking. Okay. So 10 again repeating, the CNC drive to 10, that means from BLU 5 microns to 10 microns I want without changing the table speed. Okay, so modification can be accomplished by, that means 5 microns should be converted to 10 micron. That means for BLU to 0.01 gear ratio has to be reduced to 1 by 2. Okay, because we know that feed is equal to BLU into pulse per feed, pulse per minute. So feed, since the feed value is not changing, so 50 by 0.01 is equal to 5000. I'm sorry, sorry. What is the new feed value? The feed value will be BLU into pulse per minute. Now what is the BLU? BLU, they have given 10 micron. So 10 micron is the BLU into the pulse generation. Pulse generation, I think if they have changed the value, so the pulse generation will be feed divided by BLU, which is equal to 50 per minute divided by this 0.01, that is equal to, that is 10 micron, that is 0.01 is equal to 5000 pulses per minute. Initially it was, I think, 10,000 pulses per minute, right? So it will be 5000. That means F by 2. That means F by 2 is, I think one of the option has F by 2, only one, F to F by 2. So option A will be the correct answer. Okay, I am not showing how the gear has been reduced, but looking at the feed only, we can calculate, we can see that none of the option is matching. So F to F by 2, by changing F by F2, if you observe U by 2, let us see how it is getting changed. See, if I change U to U by 2, I will be dealing with 1 by 2 into the movement of the lead screw, right? 1 by 2 into 4 into 1, that is equal to movement will be 2 Okay, so if you calculate it, you will find that it will suit our microns, means the BLU, that is 10 Okay, that means the BLU has to double it. So I'm not going much into the gear ratio, but I'm focusing on the feed value, because I found that this feed value is actually something which gives me which is unique in all the options. So I'm not intentionally changing the gear ratio, means I'm not working on the gear ratio in this particular problem. So this gear ratio, the answer is the gear ratio should be reduced from should be increased from 1 by 4 to 1 by 2, and the feed should be reduced from F to F by 2 in order to increase our BLU from 5 microns to 10 microns. So this finishes the GATE question paper. This finishes the GATE 2008 question paper. I hope you would have understand, because this was quite trickiest question paper among till now whatever we have solved. That is from 2003 to 2008. Whatever we have solved, 2008 was the trickiest. So I hope you have understood it. If you not, please comment on the please write it in the comment section, and do let me know, so that I will work on it and work on solving your queries. Thank you very much.